Welcome everybody. In this class we will be learning about inverse trigonometric functions. So the first and foremost question that we would have to ask and understand is, when can a function have an inverse? This is a very important question. When can a function have an inverse? The necessary condition, or I should say the necessary and sufficient condition for a function to have an inverse is that the function should be bijective. This is the necessary and sufficient condition. So once you check this condition, and if it is true, then the function is said to have an inverse. So next question comes is, what exactly is the meaning of bijective? So that's exactly what I'm going to define here. So let me write that down. A function is said to be bijective. A function is said to be bijective if it is both injective and surjective. Very important keywords: injective, surjective. Now, what is the meaning of being injective? When is a function said to be injective? This is a question. Answer: a function is said to be injective if it is 1 to 1. So we either write it like this or we write it like this: 1 to 1. So what is the meaning of 1 to 1? Now suppose you have a function, say f of a going on to b. We call this as domain. A is said to be domain and b is called the codomain. Now let me give you this illustration for injective. Now in A, this is set A and this is set B. So you got elements like A, B and C. And in set B, you got elements like D, E, F and G. Now if every element in A as a unique element in B, so A goes to B, A goes to D, B goes to E and C goes to G. It doesn't matter, C goes to F. It doesn't matter if G is left out, right? But the condition is every X element of A should be mapped to a unique element in B. Okay, so this is the meaning of 1 to 1. So that is the important understanding that you should have with regard to the concept of injective. So having given you that injective concept, let's move on. Now let me give an illustration to reinforce the concept of injective. Now let me have a mapping of a function from A to B such that A and B are a set of real numbers. And let me ask you this question. Say f of x is equal to 3x squared positive 2. The question is this function injective? Okay, that's the question I wanted to ask. So what are the definition for injective: for every x element of A, there should exist some y element of B such that f of x is equal to that y. So this understanding should be present in the definition. Now, what is the exact meaning of this? It means, suppose you got x1 and x2 element of A. Now, if you are checking for the function to be injective, f of x1 cannot be mapped to y with f of x2 also being mapped to y. This is a clearly no, right? So in this case, what are we trying to show here? We are trying to show here that two elements from A, this is A, x1 and x2, this is B, is mapped to a single element, or I should say to the same element y in B. So this is not injective. The condition fails. So as I mentioned to you, if I were to take this f of x is equal to 3x squared positive 2, is this, I asked you this question, is this function injective? So if I were to take x being equal to positive 2 and x being equal to negative 2, okay, f of x, in this case f of 2 will be 3 of 2 squared positive 2. This is 4, 3, 12 positive 2 gives me 14, and f of negative 2 is 3 of negative 2 squared positive 2, which is also going to be equal to 14. So two elements from A, 2 and minus 2, is being mapped to a single element, the same element 14 in B. So this would mean f of x is equal to 3x squared positive 2 is not injective. So once this condition fails, f of x is not bijective. So what does it mean? This means f of x cannot have an inverse. Cannot have an inverse. So mathematically we can say function, you can state it like this: inverse does not exist for the function. Okay, that's a better way to say inverse does not exist for the function. So the first condition fails, right? So having given you the definition of injective, let us move on to understanding surjective. So let me just reiterate one more time. If you want to check the function for injective, simple concept is it should be 1 to 1. That's it. So you look for this in the function. And having mentioned this, let us understand what is surjective. So when is a function said to be surjective? That's a question. When is a function said to be surjective? Now what is the meaning of surjective? Surjective means onto. So what is the understanding of onto? Let me state it here. If every element present in the codomain is mapped to by at least one element in the domain, then the function is said to be surjective. It's also called as surjection, and we can also call it to be as onto. So example, I got A, I got B, and we have a mapping going on from A to B. Elements in A are A, B, C, D. Elements in B are 1, 2, 3, 4. A goes to 1, B goes to 2, 3 and 4. Now every element, this is the codomain. Every element in the codomain is being mapped by at least one element in the domain. Now you have to understand, just because a function is surjective, it doesn't mean it's going to be injective. So that is an important note. Function being surjective does not imply that the function is also, in fact, will be also, you can substitute, injective, right? So don't assume that. So this assumption is dangerous, okay? So make a point of it. And on the contrary, vice versa also is true. So just because the function is injective, it will not automatically qualify to be surjective. So those are important points. Now, to briefly state is, this line of statement would be sufficient. So if you want to check for onto, the codomain should be equal to the range of the function. So you will have to understand one important concept. Say for example, the concept of codomain and range. Now if you have a function, say R going on to R, and you have f of x to be equal to, say, sin x, right? The range of this function lying between -1 less than equal to x less than equal to +1. So this is the range of the function. Now this range and this functional mapping R to R is totally different. So this one is the reach of the function, whereas this one is called the codomain of the function. So the function can take any values in R. So there is a saying in the English language, the sky is the limit. Sky is the limit. The sky is the limit, but every individual has a limit. So what is the limit of an individual? That is what we call it as range. But sky is the limit, right? So you have to have those two things in perspective. So having given you this illustration for surjective, let me concurrently give you an example for a function which isn't surjective. Say for example, you got A, B and C, and you got 1, 2, 3, 4. Say you got A going on to 1 and B going on to 2 and C going on to, say, 3. In this case 4 is left out. So this is not surjective. So you cannot leave any element on the codomain. Even one element is left out, the condition fails. Now, having mentioned all of this, let us come to inverse trigonometry functions. So far we have just discussed when a function can have inverse. So there is another word for inverse. We use it as invertible. So once the function is bijective, we call the function to be invertible. So the meaning is the function can have an inverse. Is it necessary that all functions should have an inverse? No. All function cannot, as you have just seen, have an inverse. Two conditions are imperative: surjective and injective. So both these conditions, in fact I should start with injective and surjective. The function has to be 1 to 1 and then on 2. So both these conditions have to be satisfied. So this is injective and this is surjective. Only then the function qualifies to have an inverse. Now, how do we find an inverse? Simple. I can show you how exactly to find an inverse. Okay. So before I could go on to show you how to find an inverse, we are so far dealing only algebraically. We have not gone into the trigonometric part. So I will slowly head on to the trigonometric part. As I mentioned to you, I've just asked you a question, is f of x equal to sine x? Is it bijective? So I'm asking you, is it 1-to-1 onto? So I will answer the question within a minute. So what I'm going to show you is, I'm going to show you how exactly to find an inverse for this function. F of x is equal to 2x positive 1. Now this is the function that is given. Now if I were to take, if the function is defined from R to R, now clearly just by observation you can see that this function is bijective. So once it's bijective, it will have an inverse. So what I wish to do is I would like to start off by writing like this: y is equal to 2x positive 1. Then what do you have to do is replace all x by y and vice versa. So if you see an x, you replace it by y. If you see a y, you replace it by x. So in this case, it's going to be x is equal to 2 times y positive 1. Then step 2, you rewrite the equation for y. So in other words, what I'm trying to tell you here is y should be on the left hand side. So for that, move 1 to the other side, you get 2y. So from here, therefore 2y is equal to x negative 1. This implies y is equal to x negative 1 over 2. So this is the inverse. So this means when you're writing, you write it like this: f inverse of x is equal to x negative 1 over 2. So I've got this. Now how do you check if this is the inverse? F composition f inverse of x should be equal to f inverse composition f of x should give you x. So let's check this out. So we have f of x. This is given. F of x is equal to 2x positive 1. F inverse of x is x negative 1 over 2. So consider f composition f inverse of x is nothing but f of f inverse of x. Right, which is nothing but you have to substitute f inverse of x into the function. So what is f of x? F of x is this. So 2 times of, in place of x I substitute x negative 1 over 2, right, followed by positive 1. So this is going to be x negative 1 positive 1, which is equal to x. So we got this x, you see that. So also consider f inverse composition f of x. Now what is this is equal to? This is equal to f inverse of f of x, which is nothing but, you'll have to substitute f of x inside x minus 1, so over 2. That is going to be 2x positive 1 negative 1 divided by 2. Positive 1 negative 1 gets cancelled, giving you 2x over 2 is equal to x. So this means f composition f inverse of x is equal to f inverse composition f of x is equal to x. So this means f and f inverse are inverses to each other. You don't have to state it, it's understood, right? So we have proved it that f inverse is indeed the inverse, or you can say that this means f inverse of x is indeed the inverse of f of x. So that is all about the algebraic part of it. So now the question comes is, what would be the situation if the function doesn't have an inverse? If the inverse does not exist for a function. Now there is a technique. That is exactly what we are going to apply for trigonometric functions. So having mentioned this, let us go on to understand the inverse functions from trigonometric point of view. So as I mentioned to you, the very first question is sin x bijective? That's the simple question I'm asking. Is sin x bijective? So make your choices. Is it bijective or is it not a bijective function? Can I say sin x is a bijective function, or can I say inverse exists for sin x? So if you would have made your decision, is it a yes or no, then we can move on in understanding the concepts in trigonometric perspective. So question, let me state it here. Is f of x is equal to sin x bijective? Now how are we to check for this? So let me draw the graph of sin x. So the graph is like this, it's in waveform. Now there is something called as the horizontal line test. Horizontal line test. So what exactly does it mean? Just draw an horizontal line. Now if this line cuts the curve at exactly at one point, then the function is bijective. Now if you were to see this, if you take this particular point and you're drawing a line, the horizontal line cutting the curve at this point, this point, this point, this point, this point, and this point, and so on. Infinite number of places the line is cutting the curve. But according to the definition, a function is bijective if it has to be, if it is injective and subsequently surjective. But in this case, the test for injection fails. The function isn't injective. You see that you take one particular point and you're drawing a line. That one particular point is cutting the curve at infinitely many points. So the horizontal line test fails. So the conclusion here is, if the horizontal line test fails, that would mean f of x is equal to sin x is not bijective. If a function is not bijective, then inverse doesn't exist. Now, when a function is not having an inverse, but we got an entire topic called as inverse trigonometry function, because if it's going to be failing for sin x, naturally none of the trigonometrical ratios will satisfy, because sin x is the parent, almost like a bulwark in trigonometric identities and trigonometry ratios, because everything starts with sine. And if the test is failing for sin x, then undoubtedly an element of evidence for us to state that the test would not be satisfied by other trigonometric ratios. So that's the entire idea I'm trying to infer here. If that be the state here, then what are we doing with this particular topic? Well, the answer lies in this particular unique concept called as restriction of the domain. See, in this case, there is no restriction, okay? The sin x is heading from point 0, it moves up to the right side. It will also do the same thing on the left hand side. And in this case, say for example, the wave, this is going to be hitting the point at 2 pi and so on and so forth. It is going to be the same. The pattern is going to be repeating infinite number of times, and this line is going to be hitting the curve at infinite many points. So what is the only probability or the only opportunity we got in showing that f of x is equal to sin x as an inverse, or f of x is equal to sin x is bijective, is by the concept of what is called as restriction of the domain. So what am I talking about? So I'm talking here about, let us restrict the domain, okay, to negative pi over 2 to positive pi over 2. That is the secret. So how am I going to do that? Because in this case there is no restriction. But if I were to place a restriction, let me show you that restriction. So the curve, see that? I'm just going to, this point is positive 1, this point is negative 1. The sin x curve hits the point, it's the maximum here at 1. And it's the lowest point at negative 1. So instead of moving up to 2 pi and 4 pi and 6 pi and 8 pi and so on and so forth, I want to put an end. At pi over 2, the function hits 1. So this is the point the function hits. And similarly at negative pi over 2, the function hits negative 1. So this is the point. So let me just draw this. So this is what we are going to do. And what you call such a function, this is sine function, right? But this is called as the principal sine function. So that's a technical term. So what exactly happens in the principal sine function? The domain is restricted between negative pi over 2 to positive pi over 2. So in this case, if you were to draw the horizontal line, if you were to perform the horizontal line test, right? So I take this horizontal line and I hit it. There will be just one point of intersection. This is exactly what we want. No matter where you draw this horizontal line, it will cut the curve at exactly one point. And that is what is required in proving that the function is bijective. So in general, to sum up, f of x is equal to sine x. Okay, let me write that. In general, sine x, let me write it like this, f of x is equal to sine x is not bijective. But with the restriction of domain, principal sine function is bijective. So that is the important part you will have to know. So in this case, I think we can now head on in understanding the inverse trigonometric functions. So that would be a good place for us to stop and wrap up this fundamental discussions about function being invertible. Now the next important concept is, how do we represent these functions? How do we represent the function, right? So f of x is equal to sine x with restricted domain. So we are talking about the principal sine function. In this case, f is heading from negative pi over 2 to positive pi over 2, right? And the maximum value is positive 1, minimum value is negative 1. So we always start with the minimum value and place the maximum value. So this is the representation for the principal sine function. Now, having got this, let us give the representation for the inverse function. So f inverse of x, we have already found that is represented as sine inverse of x. So when I say we have already found that, so in this case we already know the principal sine function as an inverse, and this is how we make the representation. F inverse of x is equal to sine inverse of x. And how do we give the mapping? It is given as follows: f inverse. Now over here, f is actually heading from negative pi over 2 comma pi over 2 to negative 1 comma 1. So for f inverse, it would be the exact reverse. So it will start with negative 1 comma 1 and it will head on to negative pi over 2 to pi over 2. Now one important part, whenever we are talking about inverses, we do not use the term codomain, because for the function, in particular inverse functions, a function can only have an inverse if the codomain is equal to range. So whenever we are talking about the codomain, we mean that the codomain is equal to the range, and only then the function can become onto. So that is an important part or important point you will have to know. So when we are usually referring to inverse functions, we will only talk about domain and range. We will not use this term codomain, because codomain required to be equal to the range. Only then we can clearly say that the function has an inverse. So since we have already shown that, so there is no reason for us to be utilizing or using the term codomain, right? So from here onwards, we will only be referring to the right side as range, right? So having made that clear, let us move on. Now let us write down the properties of sine inverse of x. Right, now foremost we need to draw the graph of sine inverse of x. Now clearly you can see the sine x graph is actually moving up like this. Now to get the sine inverse x graph, you will have to reflect this onto the line y is equal to x. If you were to do that, you will be able to obtain the sine inverse x graph. So how does the graph look? Now instead of opening down, the graph is going to be opening up and it will be flowing like this. So this is going to be the sine inverse of x graph. So what would be the domain? So the domain in this case, so let me write that down. The domain for sine inverse of x is going to be from -1 to +1. And next is range. The range is, so this is going to be -1 and this is going to be +1. That's important, right? So the range is going to be -π/2 to π/2. So as I mentioned to you, range is indeed the codomain here. And clearly you can see the graph is continuous. It is continuous and it is also differentiable and it is periodic and it is 1 to 1 and it is onto. So I have listed 1, 2, 3, 4, 5, 6 and 7 points. So this is in connection with sine inverse of x. So you have to remember all of these things. Now the next important question is f inverse of x is equal to sine inverse of x? Is the function symmetric? Answer this. Is it symmetric or not? Now how are you going to find if a function is symmetric or not? Now the simplest way is go to the origin. From the origin you draw a line, you get a point. Now from the same origin, subsequently to the same distance, you draw another line and you get another point. Now if you're able to do this from the origin, you can clearly say the function is symmetric. This implies the function is symmetric about the origin, right? Because from the origin you're moving up, you're getting a point. From the same origin you're moving down, you're getting another point. So if you were able to connect this, clearly you can, with concrete definiteness, you can say that the function is symmetric about the origin. Now subsequently, so let me write that down. Point number 8, the function is symmetric about origin. And point number 9, once the function is symmetric about the origin, the function is called as an odd function. So the requirement for a function to be odd is the function has to be symmetric about the origin. And once it is symmetric about the origin, the function is an odd function. So those are some of the important critical informations that we will have to know with regard to sine inverse of x. Now, since I've given you 9 points, let me also give the 10th one. The question is the function increasing and is the function bounded? Now clearly if you were to be heading from the origin up, if the function is indeed increasing, and you can clearly see the range is actually -π/2, π/2. So the 10th point is the function is increasing and it is bounded. Okay, so 10 important points we have given for sine inverse of x. Now likewise we can also give these important points for other inverse functions like secant inverse of x, cosecant inverse of x, cos inverse of x, tan inverse of x, cotan inverse of x. Now it becomes necessary that we know all of these graphs. Now foremost, I'm going to teach you a technique by which you can with ease draw all of these inverse trigonometric functions graphs. Now foremost, let us start with cosecant inverse of x. Now what is cosecant x? Cosecant x is the reciprocal of sine x. Now just make the observation for sine x graph. Now the graph is in this fashion. Now how are we going to draw the cosecant x inverse graph? Now wherever the function ends, the cosecant x inverse starts. So in this case it ends here. So if you were to draw the graph, let me show you over here how to draw this graph. Right. So clearly you can see the sine x graph ends at this point. So wherever it is ending, you start the cosecant x graph from there. So this is ending here. So from here I'm starting cosecant x and you move up like that. That's it. Now it ends here. So from here you move out like that. So what is this? With ease we have got cosecant inverse of x graph with ease, right? Of course these points would be 2 and 4 and so on and so forth. So it will be moving up to plus infinity on the right side, and this is going to be -2, -4, moving all the way to negative infinity, right? And this point is 0. So on the right side cosecant inverse of x is heading towards positive infinity, on the left side it's heading towards negative infinity. So this is the method for drawing cosecant inverse of x. So let's also see how to draw cos inverse of x and secant inverse of x. Now let's look into the graph of cos inverse. So the graph of cos inverse of x looks in this fashion. So let me draw that. So the graph is going to be heading down. If this point is 1 and this is 2, it will move up and down like this, and this is going to be 1. So this is the graph of cos inverse of x. Now having drawn the graph of cos inverse of x, we will have to draw the graph of y is equal to secant inverse of x. Now how do we draw that? Let me show you that. Now wherever the graph ends for cos inverse of x, secant inverse of x begins. So it is ending over here. So what you do is start from here and move down. Now similarly it is ending over here. This point is 1, right? Now from here you move up. So there is actually an asymptote here. So this is going to be the graph of secant inverse of x, and it looks really beautiful. So we've got the graph for cos inverse of x, secant inverse of x, cosecant inverse of x, sine inverse of x, and all it remains is tan inverse of x and cotan inverse of x. The last two remaining graphs are y is equal to tan inverse of x. So let me draw this graph. Y is equal to tan inverse of x. The graph will look something of this fashion. And it will actually go down like this. So this point which you see here and this point it doesn't touch here, right? It's an asymptote. This is going to be plus pi over 2 and this is negative pi over 2. So this is for tan inverse of x. Now let me show you cot inverse of x. How does that look? Now tan inverse of x goes like this. Cot inverse of x will go like the exact opposite side. So let me draw that. So the graph would be hitting the point like that and moving down like this. So we will have to draw the asymptotes. Okay, so this point is going to be pi. Now one important observation is that it doesn't come to the negative side. So this is 4 and this is 5. The graph will never come to the negative end. So that would mean cot inverse of x is always positive. So it's always on the upper half. So that's an observation. But in this case it's not so. It comes down, right? So have that in mind. So having given these graphs, it's time for us to start problem solving. Now the very next important concepts that we have to look in with regard to inverse functions is the concept of domain and range. Now many of the questions are focused on this particular concept, domain and range. So foremost, let me just write down the heading, the function and its domain and its range. So to start off with, the function is y is equal to sine inverse of x, function 1. Its domain is between negative 1 less than equal to x less than equal to 1, and its range is negative pi over 2 less than equal to y less than equal to positive pi over 2. That's the first thing. So next is obviously y is equal to cos inverse of x, and its domain is negative 1 less than equal to x less than equal to 1, and the range is 0 less than equal to y less than equal to pi. So it's a positive function. So when I say positive, it doesn't come down to the other half, the negative end, right? So moving on, y is equal to tan inverse of x. The domain is all x element of real number, and the range is pi over 2 strictly less than y, strictly less than pi over 2. So this negative pi over 2 strictly less than y less than pi over 2. So you can clearly see that from the graph. So all of these concepts which I am just placing here are clearly observant from the very graph which I have just shown you a few minutes ago. So moving on, for y is equal to cot inverse of x. In cot inverse of x, it's all x element of real number, and it is strictly on the positive side. As I mentioned to you from the graph, it doesn't come down at all. So that's the graph for cot inverse, or I should say the range for cot inverse of x. So 5, y is equal to cosecant inverse of x. this is all x less than equal to -1 or all x greater than equal to +1. This is clearly observed from the graph. And the range is going to be -pi/2 less than equal to y less than equal to pi/2, and y is never equal to 0. Number 6, y is equal to secant inverse of x. This is x less than equal to -1 or x greater than equal to 1, and the value is 0 less than equal to y less than equal to pi, and y is never equal to pi/2. So that's for secant inverse of x. So clearly from the range you can clearly find out if the function is increasing or decreasing. So having given you all this, we will head on. Now when it comes to remembering the range for these functions, it is sufficient that you remember the following groups. So sine inverse of x, tan inverse of x, and cosecant inverse of x, they all are present in one group. So how am I going to remember it? Now sine inverse of x, it's well known fact that the range is between -pi/2 and pi/2, right? Now for tan inverse of x, now this is closed interval, right? For tan inverse of x, the interval becomes open. So this is completely closed. This is open. Now when you come to cosecant inverse of x, cosecant inverse of x is nothing but the reciprocal for sine. Cosecant is the reciprocal for sine, right? So cosecant inverse of x will have something similar to the sine inverse of x. So that is the reason that the range is between -pi/2 and pi/2. But apparently y is not equal to 0 here. So have that in mind. So sine inverse of x, tan inverse of x, and cosecant inverse of x, they all fall in one group. And we start with closed interval, and then an open interval, and then again a closed interval, with one exception that y is not equal to 0. Now coming to the cos inverse of x. Now as I mentioned to you, the only other remaining group is cos inverse of x, cot inverse of x, and secant inverse of x. Secant inverse of x is the reciprocal for cos inverse of x. So there will be a similarity. Now cos inverse of x, in this case it starts with -pi/2 and pi/2. But cos inverse of x is between 0 and pi, and it is closed interval. So cot inverse of x is going to be open. You follow me? This is 0 less than equal to y less than equal to pi. This is going to be 0 strictly less than y strictly less than pi. And the secant inverse of x is exactly going to be what you got for cos inverse, with one exception, that y cannot be equal to pi/2. That is the only exception that is placed in secant inverse of x. So this is a good technique, and you will never forget this if you are going to be using the strategies that I'm just showing you here. You will never forget the range of these inverse trigonometric functions at all. Let's do this question, students. This was asked in JEE Mains 2021. Right? So the question is as follows. Let f of x be equal to cos of 2 times tan inverse of sine of cot inverse of square root of 1 negative x divided by x. There is a parenthesis here. And so this is for this, and you got a parenthesis here, and then you got another parenthesis. So this is given, and you're also given that x is lying between 0 and 1. Then the choice are, is it 1 negative x raised to the power of 2 times f dash of x negative 2 times f of x raised to the power of 2 is equal to 0? Which of these equations will be true? That's the requirement for this question. So 1 positive x raised to the power of 2 f dash of x positive 2 times of f of x raised to the power of 2 is equal to 0. And then c is 1 negative x raised to the power of 2 f dash of x positive 2 times f of x raised to the power of 2 is equal to 0. Or d 1 positive x raised to the power of 2 f dash of x negative 2 times f of x raised to the power of 2 is equal to 0. So which of these equations is said to be true if the function is given in this fashion? So having given you this question, let's move on to the next page and work out the solution. So foremost, let us consider the given question. So let me write that down here. Consider f of x being equal to cos of 2 times tan inverse of sine of cot inverse of root of 1 negative x over x. Right, this is given. So what I wish to do is I would like to now take cot inverse of root of 1 negative x over x to be equal to some theta. So this would mean cot theta is equal to root of 1 negative x divided by root of x. So if I were to use the trigonometric laws, this is my theta, this is cot theta. Cot theta is adjacent over opposite. So this is going to be root of 1 negative x and this is going to be root of x. Right, now if you want to get the hypotenuse, you can very well do that. So hypotenuse is equal to, if I were to take this as a, b and c, ab squared positive bc squared is ac squared. You square it, you get 1 negative x. You square it, you get x. And this is ac squared, so therefore ac is equal to 1. So this is going to be 1. Now if you were to find sine theta is equal to root of x divided by 1, which is nothing but root of x. So this is my sine theta. Now you might be wondering, why did I take sine theta? Now if you were to take this as 1, therefore 1 can be rewritten as f of x is equal to cos of 2 times tan inverse of sine of, now cot inverse of this entire quantity is taken to be a sine theta. So this is my, in fact it's taken as theta. So this is going to be producing theta. So this is sine theta and I've got a parenthesis. You don't have to place parenthesis, just for the sake of some level of identification. So this is equal to cos of 2 times of tan inverse of, now what is sine theta? Sine theta is going to be root x. So this is root x. So now what I've got cos of 2 times of tan inverse of root x. Right, this is my f of x. So now what I'm going to do is I want to take, let tan inverse of root x be equal to some phi. So this would mean tan phi is equal to root x. Right, so if I were to substitute this, this is going to be equal to cot 2 times of tan inverse of root x is equal to phi. So this is going to be phi. So I have f of x to be equal to cos 2 phi. Now if I were to rewrite this in terms of tan, this is going to be 1 negative, we know we have already seen this formula, 1 negative tan squared phi divided by 1 positive tan squared phi. But what is tan phi? Tan phi is nothing but root x. So 1 negative root x raised to the power of 2 divided by 1 positive root x raised to the power of 2, which is nothing but 1 negative x divided by 1 positive x, which is my f of x. So therefore f of x is equal to 1 negative x divided by 1 positive x. This is my f of x. Now I need to find out f dash of x. Why? Because the choice involves f dash of x. So f dash of x is equal to u over v differentiation. So 1 positive x times the differential of 1 negative x is negative 1. Negative 1 negative x times differential of 1 positive x is 1 divided by 1 positive x raised to the power of 2. This is going to be negative 1 negative x negative 1 positive x divided by 1 positive x raised to the power of 2. Positive x negative x gets cancelled, giving me negative 2 over 1 positive x raised to the power of 2. So this is my f dash of x. Now what I wish to do is I will have to get a f of x square, because in the output, in the choices, every quantity has got an f of x. But f of x, what is f of x? F of x is 1 negative x divided by 1 positive x. But as I mentioned to you, all of the choices have got f of x raised to the power of 2. So what I would like to do, I would like to rewrite this as negative 2 divided by 1 positive x, right? So there is already a square there, so I don't have to do anything for the denominator, but I will have to bring this term here. So I'm multiplying it by 1 negative x raised to the power of 2. If I were to do that, subsequently I will have to multiply the left hand side by 1 negative x raised to the power of 2, right? So rewriting, if I were to rewrite this, this is going to be equal to negative 2 times, I can write this as 1 negative x divided by 1 positive x raised to the power of 2. But what is this? This is nothing but f of x. So this is equal to negative 2 times f of x raised to the power of 2. And on the left side I get 1 negative x raised to the power of 2 into f dash of x. Now I move this to the left hand side, I get 1 negative x raised to the power of 2 times f dash of x positive 2 times f of x raised to the power of 2 is equal to 0. So this is what I've got. Now you have to go and check back the choices. So let me show you this choice. So before I could flip the page and move to the previous page, just make sure that this is written at the corner of your mind. 1 negative x raised to the power of 2 f dash of x positive 2 times f of x raised to the power of 2 is equal to 0. So this is the choice we are looking for. So now clearly you can see that 1 negative x raised to the power of 2 times f dash of x positive 2 times f of x raised to the power of 2. This is the only thing that is available, which corresponds to our required output that we just received. So C is the answer. D cannot be, A cannot be the answer because it's negative here. But this is our solution. So having got that, we'll move on to the next question. Now this question was asked in JEE Main 2021. So we're going to do this question now. The question is a possible value of tan of 1 over 4 sine inverse of root of 63 over 8 is, this is what is asked. Right now you've been given list of choices. One is 1 over 2 times root 2, 1 over root 7, root 7 negative 1, and 2 times root 2 negative 1. So these are the choices that have been given. So how are we going to do this question? So foremost, let me just take sine inverse of root of 63 over 8 to be equal to theta. So this would mean my sine theta is root of 63 divided by 8. So if I were to draw the right triangle, this is theta, opposite side is 63 with the square root, hypotenuse is 8. If I were to take this as A, B, C, AB squared positive BC squared is AC squared. AB squared I don't know. BC squared is 63. AC squared is 64. So AB squared is 64 negative 63, which is 1. So AB is equal to 1. So this is 1 unit. So sine theta is 1 unit. So therefore, let me write down cos. Cos theta is going to be 1 over 8. This is a beautiful value. So if I were to take this as 1, therefore I can rewrite 1 as tan of 1 over 4. Now sine inverse of this quantity, that's going to be equal to theta. So this is going to be 1 over 4 theta. So we are actually trying to get tan of theta over 4. A very unique result that is required for this question. Now what I wish to do is I would like to connect a formula. What is the formula? Square root of 1 negative cos x divided by 1 positive cos x. What is this equal to? This is equal to root of 2 times sine squared x over 2 divided by root of cos squared x over 2, which is nothing but sin x over 2 divided by cos x over 2, which is nothing but tan x over 2. So this is the formula we have. Tan x over 2 is root of 1 negative cos x divided by 1 positive cos x. Right? But we wanted tan theta over 4. So clearly, if you were to compare this with this, over here you got x over 2, over here we got x, so that means the angle gets doubled. So therefore I wish to write tan theta over 4 to be equal to root of 1 negative cos theta over 2 divided by 1 positive cos theta over 2, right? Now we got cos theta is equal to 1 over 8, so we will have to extract cos theta over 2. So let me give you this formula. Now we know that I'm using the variable t because I don't want to use theta. Now cos 2 theta is nothing but 2 times cos square theta negative 1, right? Now if I were to take 2 theta to be equal to 2t to be equal to theta, then this is going to be cos of theta is equal to 2 times cos square t is going to be theta over 2 negative 1, right? So I've got a beautiful formula which I can use. So that is exactly what I'm going to do. So from here I'm going to use the space here. So from here I got cos theta positive 1 is equal to 2 times cos square theta over 2, which would mean cos theta positive 1 divided by 2 is equal to cos square theta over 2. I need only cos theta over 2, so therefore cos theta over 2 is equal to root of cos theta positive 1 divided by 2. But I know cos theta. Cos theta is 1 over 8, so I substitute that value. So this is equal to root of 1 over 8 positive 1 divided by 2, so which is equal to 8 added with 1, that's going to be 9 over 8 multiplied with 2, right? When you flip it, you're going to get 1 over 2, that's going to be 16. So this is the root value for this, which is nothing but 3 over 4. So this is my cos theta over 2. So take this value and substitute it here. So this is equal to root of 1 negative 3 over 4 divided by 1 positive 3 over 4. This is equal to root of 4 negative 3, that's 1 over 4 divided by 4 with 3, that's going to be 7 over 4. So you flip this, this is equal to 1 over 4 times 4 over 7, which is going to be root of 1 over 7, right? 4 gets cancelled, 1 over 7, which I can rewrite it as 1 over root 7. So what is this value? This value is nothing but tan of 1 over 4 of sine inverse of root of 63 divided by 8. Right? So this is 1 over root 7. So let's go to the choice. So if you were to go to the choice, you will clearly see that B is the right answer. So let me tick that. So that is the solution for this question, students. It's a lovely question. We will move on to the next one. Students, this next question occurred in JEE 2018. So let's see the question. The question is given as follows. If 0 less than x less than 1, then root of 1 positive x squared of x times cos of cot inverse of x positive sine of cot inverse of x. This entire thing is raised to the power of 2 followed by negative 1, and that is raised to the power of 1 over 2 is equal to what? This is required. Right? Now there are a list of choices, so probably I will place in those choices. So choice number 1, is it x over root of 1 positive x squared? Choice 2, is it x? 3, is it x times root of 1 positive x squared? Choice D, is it root of 1 positive x squared? So you got 4 choices. So let's get the solution. So foremost, if you can see this question, the question as cot inverse of x, right? So solution, I'm going to start it in this fashion. Let cot inverse of x be equal to theta. So this would mean cot theta is equal to x. I'm going to write it as x over 1. So if I were to draw the right triangle, cot theta is adjacent over opposite. So this is going to be x and 1. Of course this is theta. If I were to take this as a, b and c, I want to find AC. So AB squared positive BC squared is equal to AC squared. AB squared is x squared, BC squared is 1. So therefore AC is equal to root of 1 positive x squared. So this is going to be root of 1 positive x squared. So we got that. So having got that, if I were to take this as 1, so I can rewrite 1 can be rewritten as root of 1 positive x squared times x times cos, cot inverse of x is taken as theta, this is theta there, positive, right, sine of cot inverse of x is theta, and this is raised to the power of 2 followed by negative 1, and that in turn is raised to the power of 1 over 2. So this is what we've got. So now from here I can get cos theta. Now what is cos theta here? From here, cos theta is equal to x over root of 1 positive x squared, that is cos, and what is sine? Sine theta is equal to 1 over root of 1 positive x squared. So if we were to replace that in the given function or in the given expression, that would give me root of 1 positive x squared of x times, now cos is x over root of 1 positive x squared, positive, sine is 1 over root of 1 positive x squared, right? And this is raised to the power of 2 followed by a negative 1, that is raised to the power of 1 over 2. This is equal to root of 1 positive x squared. Now if I were to take the LCM as root of 1 positive x squared, and that would give me x squared positive 1, right? This is raised to the power of 2 followed by a negative 1, and this is raised to the power of half. So this is actually x squared positive 1 divided by root of 1 positive x squared. So can I not write this as root of 1 positive x squared? This is raised to the power of 2 followed by a negative 1 raised to the power of 1 over 2. Can I not do that? Now square root and square, they both get cancelled, giving me root of 1 positive x squared. This is going to be 1 positive x squared negative 1, and that is raised to the power of 1 over 2, right? Positive 1 and negative 1 can be cancelled, and that is going to give me x squared raised to the power of 1 over 2. What is that? Square root of x squared will give me x. So the solution is going to be x times root of 1 positive x squared, and we have to look for this value. So where is it? Clearly our focus goes on to this choice, right? X times the root of 1 positive x squared. So this is the correct choice for this question. So that is the end of the solution, students. We will move on to the next one. Welcome, students. In this particular chapter we will deal with questions that are connected to domain and range. So we got the first question: find the domain of f of x such that f of x is given to be equal to sine inverse of x negative 3 divided by 2 followed by a negative sign log of 4 negative x to the base 10. Now we know that this is the solution. We know that the domain for f of x equal to sine inverse of x is lying between negative 1 less than equal to x less than equal to 1, and the domain for log is actually greater than 0, right? It's only positive values that can be affected by log. So knowing these two information, let us now place in the given quantity. So from the question we know that x negative 3 over 2 is less than equal to negative 1, and on this side it's greater than equal to negative 1 and less than equal to positive 1. So this is the region, right? Now what I wish to do is I would like to get rid of this 2, so I would multiply by 2. This would give me negative 2 less than equal to x negative 3 less than equal to 2. Now I would like to get rid of this negative 3, so I add positive 3, positive 3, positive 3. So that in turn would give me negative 2 added with positive 3 is going to be positive 1 less than equal to x less than equal to 5, right? So this is obtained. Now let us head to log. As I mentioned to you, this is only possible if 4 negative x is greater than 0. Now if I were to move x to the other side, I would get 4 is greater than x. In other words, I can also rewrite this as x is less than 4. Now you got two regions. Let me just draw the number line. This is 0, 1, 2, 3, 4, 5, and for the first set, for this x, this is going to be the region, right? But we will have to take the composition of this with this. Now x less than 4. X less than 4 is all values that are lying below 4. So this would be the point. So from here to there, right? But the only point that we have to note here is this is an open interval. So therefore when we are writing, therefore the solution is closed interval 1 comma open interval 4. Now there were 4 choices given for this question. Choice 1 is it between 1 comma 5. So they are asking us to find the domain, right? Find the domain. So they have given it as an MCQ. And choice 2 is 1 comma 4 with the other end being open. And the other one is 1 comma 4. The final one is 1 comma 4. Right? This is open interval. So clearly we can easily see that choice B is the right solution. Right? So we will move on to the next question. Students, the next question was asked in JEE Main 2021. And let's see the question. So we are expected to find the domain of the function cosecant inverse of 1 positive x divided by x. So we are being given the following choices. So A, negative 1 comma 1 over 2, of course there's a negative sign there, union 0 comma infinity, choice A. Choice B, negative 1 over 2 comma 0 union 1 comma infinity, and choice C, negative 1 comma 2 comma infinity negative 0, and choice D is negative 1 over 2 comma infinity negative 0. Right? Now we have to make the following observation for the solution. Now if f of x is equal to cosecant inverse of x, then the domain is given to be as all x less than equal to negative 1 or all x greater than equal to positive 1. So either this or this. So we are being given cosecant inverse of 1 positive x divided by x. Okay, now consider f of x is equal to cosecant inverse of 1 positive x over x. So this would mean 1 positive x over x is less than equal to negative 1 or 1 positive x over x is greater than equal to 1. Right? So from here, if I were to move this negative 1 to the other side, I would get 1 positive x over x, positive 1 less than equal to 0. And this would be, if I were to take x to be the LCM, I would get 1 positive 2x less than equal to 0. Right? On the other side, this is going to be, and I want to move this 1 to the other side. This is going to be 1 positive x over x negative 1 greater than equal to 0. If I were to take the LCM, I would get 1 positive x negative x divided by x greater than equal to 0. Positive x negative x gets cancelled, giving me 1 over x greater than equal to 0, which means x is strictly greater than 0. Now over here, now clearly you can see that the points where this quantity will be less than equal to 0 would be from negative 1 over 2, and x cannot take the value 0. This point is 0, x cannot. So this is closed and this is open. So only in this particular segment this inequality will hold good, right? So this is found out, and this is also found out. X is strictly greater than 0 means we have collection of all points between 0 comma infinity. Both of them are open. So we will have to unite these two intervals. So this is actually -1/2 comma 0. This is open, this is closed. So therefore the solution is going to be closed -1/2 comma 0 union 0 comma infinity. So let us check it out. Which of these choices, if we have to check this out, -1/2 comma 0, 0 is not included, 0 is not included, and we go all the way up onto infinity. So of all these choices, D is the right choice. -1/2 closed to infinity and 0 is taken out, right? So this is the right solution. Students, now we will talk about decreasing functions. Now in inverse trigonometric functions, there are three main decreasing functions which we can focus on. Foremost, cos inverse of x. Number 2, cot inverse of x. Number 3, cosecant inverse of x. So cos inverse of x, cot inverse of x, cosecant inverse of x. Now, whenever you are multiplying an inequality with one of these, the inequality will get reversed. Say for example, you got 3 is greater than 2, and that you are multiplying this inequality by cot inverse of x. Say for example, you are applying cot inverse. So this is going to be cot inverse of 3. I'm not placing the inequality. Let me just place cot inverse of 2 on the other end. So now we started with this 3 greater than 2. Now when we reach for this, the inequality will get reversed. So instead of saying 3 greater than 2, now it's going to be cot inverse of 3 lesser than cot inverse of 2. Now if you were to find the value of cot inverse, this is going to be 0.322, and cot inverse of 2 is going to be 0.464. You can clearly see that our concept of reversing the inequality is holding good here, holds good, because cot inverse of 3 is 0.322 and cot inverse of 2 is 0.464, right? So that's exactly what we've been talking about. So have that in mind. Now if in case you are removing the decreasing function, so this is when you add. When I say add, it means the product, right? So it also includes, in case of systems of equations, if you are adding a decreasing function, that is also taken into consideration. So this is when you add a decreasing function, right? So this exactly happens. On the other end, if you remove the decreasing function, if you remove, say for example, you are removing cot inverse from this inequality. So what happens? It means this inequality has to be reversed. So 3 is greater than 2. You follow me? When you bring the decreasing function, the direction of the inequality changes. Similarly, when you remove the decreasing function, again the direction of the inequality changes. So this is a beautiful concept and it is worth taking note of. So next is we will be dealing with problems connected with decreasing functions. Let's do this question, students. We are expected to find the domain of the function f of x is equal to square root of 3 times cos inverse of 4x negative pi. Now there are two parts in this inequality. Now the first part is this entire quantity should be greater than or equal to 0, right? So that's exactly what I'm going to do. So 3 times of cos inverse of 4x negative pi. should be greater than or equal to 0 for the function to exist. Now the second part, this is part 2, is this value x. Now we know that if f of x is equal to cos inverse of x, then the domain is lying between -1 and +1 for cos inverse of x. But instead of x, I've got 4x. So in this case, it's going to be -1 less than or equal to 4x less than or equal to +1. This is what we've got. Now let me handle this first. So if I were to divide by 4, this is going to be -1 over 4 less than or equal to x less than or equal to 1 over 4. So this is already completed. Now let me head to the part 1. Now what I wish to do is I would like to move this pi to the other side. So it's going to be 3 times of cos inverse of 4x greater than or equal to pi. Now this 3 can be brought down, so there's going to be cos inverse of 4x greater than or equal to pi over 3. Now I need to evaluate this pi over 3. So what I wish to do is I would like to multiply by cos on both sides. So this is going to be cos. Now I already mentioned to you, when you perform this, the inequality has to be flipped, right? So the new inequality is going to be cos inverse of 4x. This inequality gets reversed, so it's going to be less than or equal to cos of pi over 3, right? Now this is 60. Cos 60 is less than or equal to 1 over 2. Cos and cos inverse gets cancelled, giving me 4x. So x is less than or equal to 1 over 8. So this is the solution. For this inequality, right? Now what we have to do is we have to club these two together. So the solution is going to be x less than or equal to 1 over 8. In this case, it's going to be between -1 over 4 and 1 over 4. So we will have to stretch all the way to 1 over 8. So closed interval -1 over 4, that's the smallest value, and then it goes all the way up unto 1 over 8. So this is the solution for this particular question. Now what happens is they have given us choices. So choice number A, let me write down those choices. Choice A is -1 over 4, 1 over 8. Choice B is 1 over 8, 1. Choice C is 1 over 8, 1 over 4. And choice D is -1, 1 over 8. Right, so clearly we can see that -1 over 4, 1 over 8, choice A is the right answer for this question. Students, we have been given another beautiful question. This question appeared in JEE Mains 2019. The question is as follows. We are expected to find all x satisfying the inequality cot inverse of x raised to the power of 2 followed by -7 cot inverse of x positive 10 greater than 10, it's greater than 0. Okay, so we are being given a list of choices, and the question continues. Lie in the interval. So we have following choices. A is -∞, cot 5 union cot 4 comma cot 2. B is cot 2 comma infinity, and C is infinity comma cot 5 union cot 2 comma infinity, and D is cot 5 comma cot 4, right? Now clearly you can see from the choices you cannot pick up a choice or pick out a choice by guesswork. That is not going to be working out. we need to really solve it. So foremost, let me just give you the solution, how exactly to get this. Now consider cot inverse of x raised to the power of 2 negative 7 times cot inverse of x positive 10 greater than 0. Now I'm going to take, let t be equal to cot inverse of x. So substituting this, if you were to take this as 1, therefore 1 can be rewritten as t squared negative 7 times t positive 10. This is greater than 0. Now this is a quadratic in t, and it can be factored as t negative 5 times t negative 2 greater than 0. So from here I can write, there are two values possible, right? So 2 and 5. So either t is less than 2 or t is greater than 5. But t is cot inverse of x, right? So that would mean I got cot inverse of x less than 2 or cot inverse of x greater than 5. Now if you were to see the graph of cot inverse of x, you will realize that the graph is actually contained with pi being the bound. So let me just show you the graph. So this is pi. It starts from 0, goes up to pi. If I were to draw the graph is going to be like this. Okay, and the value of pi is approximately 3.14. But over here it says cot inverse of x is greater than 5. So this is actually not possible. Not possible. And so we have to reject this value. So just drop this. Right? This is dropped. So we are left with cot inverse of x less than 2. Right? If I were to move cot inverse to the other side, I would get x is, in fact, if I were to apply cot on both sides, I have clearly mentioned to you that we are dealing with a decreasing function, right? So the inequality will get reversed. So this is going to be cot of cot inverse of x, and this is going to be cot 2. So the inequality will get reversed like this, and cot inverse will get neutralized, giving me x greater than cot 2. So all values of x that is greater than cot 2. So the solution for this is going to be cot 2 comma infinity. So this is going to be the solution, right? So let's go back to the choices and see which of these is matching. Clearly you can see B, cot 2 comma infinity. So this is the right choice for this particular question. Welcome students. This question was asked in JEE Advanced 2015. We got a beautiful question, and the question is as follows. If alpha is equal to 3 times sine inverse of 6 over 11 and beta is equal to 3 times cos inverse of 4 over 9, where the inverse trigonometric functions take only the principal values, right? We have already studied about principal values. Then the correct choices are, so the question can be the correct choices are what I would want to say is it can either be a singular tone or a plural tone, right? So depending upon what the choices are. In other words, a question might have 3 solutions or 4 solutions or 5 solutions, right? So we should not restrict our thought process to just locating one solution. So that is exactly what the question wants. The question wants you to find out all possible solutions. So I am just placing here correct choices are. So it can even exist just one solution. So in that case, then the correct choice is, right? So you can rephrase it as you wish depending upon the availability. So I would like to suggest that you keep your mind broad and expect different probabilities of results. So having mentioned that, we got the choice. A, is it cos beta greater than 0? B, is it sin beta less than 0? C, is it cos of alpha positive beta greater than 0? D, is it cos alpha less than 0? So we have 4 choices. Now among these 4 choices, you might find only one choice that is suitable for this question, or 2 choices suitable for this question, or 3, or even all the 4. So that is exactly what I wish to say. Now we have been given alpha is equal to 3 times sine inverse of 6 over 11. Now we got 6 divided by 11, but I have no clue what is 6 over 11. Sine inverse of 6 over 11, I am totally not aware of a value like 6 over 11, a standard value. Of course, we can always adopt the use of calculator and extract the value of sine inverse of 6 over 11. But as of now, out of my mind, I wouldn't be able to tell the value of sine inverse of 6 over 11. So in that case, what I wish to do is I would like to make a comparison. Now clearly 6 over 11 is greater than 6 over 12, right? This we know. So this is one type of technique in mathematics. Whenever you are given certain challenging questions, you can always associate the question to a known question whose solutions are well aware to your knowledge, and then boil the solution down to the requirement. So that is exactly what I'm doing. I'm just taking 6 over 11 and I'm comparing it with 6 over 12. Of course, I know what a 6 over 12 is. So I'm taking sine inverse on both sides. So this is going to be sine inverse of 6 over 11. This is going to be greater than sine inverse of 6 over 12, right? Now sine inverse of 6 over 12 is nothing but sine inverse of 1 over 2. This is a standard value, we all know. Now this is as such 6 over 11. So this is the next step. Now I need to have a 3 here. You can clearly see there is a 3 that's been multiplied. So let us multiply 3 on the left side. 3 times sine inverse of 6 over 11. And this is greater than 3 times sine inverse of 1 over 2. So that's fine. Now this is given to be as alpha. If you were to check the question, it says alpha is equal to. So let me just take alpha. It's given. So alpha is greater than. Now 3 times sine inverse of 1 over 2. That's nothing but 60 degrees. 30 degrees, not 60. Sine 30 is 1 over 2, right? So that would mean the value of this quantity, angle, is going to be pi over 6, right? Sine pi over 6 is going to be 1 over 2. So this is well known. So I would like to take that and place it here. So 3 times of sine inverse of 1 over 2 is pi divided by 6. So this implies alpha is greater than 3 divided 6 2 times. So pi over 2. Now when you see something like this, alpha is greater than pi over 2, the understanding that we should draw here is to first draw the quadrants. So this is 0, this is 90, this is 180, this is 270, and this is 360. Now 90 is over here. alpha is greater than pi over 2 means it should only be in the second quadrant. So whenever we talk about a quantity greater than an angle, you have to always understand that it would be slightly larger, right? It won't be so large that it will skip to the next quadrant. From quadrant 2 it won't go to quadrant 3. It will be slightly larger. So in this case alpha is greater than 90 degree means it would be present in quadrant 2. That is the understanding we should draw. Now in quadrant 2, if we were to represent this by CAST, only sign is positive. So having mentioned that sign is positive, so that would mean cosine is negative, right? So if I were to take cos of alpha would be less than 0. So let us go to the choices and examine it. So if you were to see here, this is beta, we don't need this. Alpha plus beta, we are still yet to find beta. So this is out of the question. Now you got cos alpha is less than 0. This is exactly what I was just mentioning here. Cos alpha less than 0. So cos is negative. So this is a exact right choice. I shouldn't say use the word exact. This is a correct choice for now. Now let us go up and obtain the value for beta. Now what is beta? Beta says 4 over 9. So I can very well do that working over here. So clearly, as I mentioned to you in the earlier case, just associate 4 over 9 to a value that you already know. Clearly I know 4 over 9 is less than 4 over 8. 4 over 8 is nothing but 1 over 2. Now this has got cos. So I'm attacking by cos. Now cos is a decreasing function. So whenever you are taking cos inverse of a value, the inequality gets reversed. You should understand cos inverse is a decreasing function, whereas we not reverse the inequality for sine. The reason being sine inverse is an increasing function. So since cos inverse is a decreasing function, the inequality will get reversed and we can write it like this. Cos inverse of 4 over 8 is nothing but 1 over 2. So that's fine. Now I wish to multiply by 3 both sides. So there's going to be 3 times cos inverse of 4 over 9. This is greater than 3 times cos inverse of 1 over 2. This is what we have got. So now what I wish to do is I would like to replace 3 times cos inverse of 4 over 9 by this quantity beta, right? That's the exact representation that is being given in the question. So let us use the data from the question. So we now have beta is greater than 3 times. Now cos inverse of 1 over 2, that's going to be cos 60, right? We know that cos 60 degree is equal to 1 over 2. Now how do I represent cos 60 degree? Cos 60 degree is nothing but pi over 3, right? Cos pi over 3 is 1 over 2. So this is going to be pi over 3, right? So what happens here? 3 and 3 can be cancelled. So beta is greater than pi. Now beta is greater than pi. Let's go to the quadrant representation. So this is 180 degree. So this would fall in third quadrant. Beta greater than pi. So only tan is positive. So let's go back to the choices. Surely this cannot happen, right? They are saying cos beta is greater than 0. This is not possible. Sin beta is less than 0. Yes, sin is negative here. That's fine. So I've got B, I've got D. Now we need to check for alpha plus beta. Now this is the check for alpha plus beta. So what is alpha? Alpha is actually greater than pi over 2. So let me just write that down. Alpha positive beta. Therefore alpha plus positive beta is greater than pi over 2. Positive beta is greater than pi. So place that. So what is this? This is equal to 2 pi plus pi. So this is going to be 3 pi over 2. So this would mean alpha positive beta is greater than 3 pi over 2. Now what is 3 pi over 2? That's nothing but 270 degrees. So alpha positive beta is 270 degree means it will skip or it will just move to the fourth quadrant. In fourth quadrant, cosine is positive and its reciprocal is positive, right? Cos is positive along with its reciprocals. So let us go and check over here. So clearly you see this is exactly what they have given. Cos of alpha positive beta is greater than 0. So this is perfectly correct. So as I mentioned to you, you should have ticked. If you were to encounter a question of this fashion, in your examination, either in competitive examinations or examination for some scholarships or for some master's degree program, you should have selected B, C, D as the right choice. It doesn't matter if you were to select the C and then leave B and D off. You wouldn't get the score. So you have to select B, C, D. So this is the right choice, B, C, D. Right? So have that in mind. So having mentioned that, let us move on to the next question. Students, we are given another beautiful question. The question is as follows. If cos inverse of x added with cos inverse of y added with cos inverse of z is equal to 3 pi, then we are expected to find the value of x raised to the power of 2024 positive y raised to the power of 2024 positive z raised to the power of 2024 positive 6 divided by x raised to the power of 2023 positive y raised to the power of 2023 positive z raised to the power of 2023. So we have the following choices being given. Choice A is 0, B is 1, C is -1, and D is 2. So these are the choices we have been given. Now let us consider the question. Consider cos inverse of x positive, cos inverse of y positive, cos inverse of z is equal to 3 times pi. Now I would like to ask you, when is this possible? Left hand side should be equal to right hand side. When can this occur? Now clearly you can see that this is only possible if cos inverse of x becomes equal to pi, along with cos inverse of y becomes equal to pi, along with cos inverse of z being equal to pi. This is the only possibility that is available for us to make the left hand side equal to right hand side. There is no other way that left hand side would be equal to right hand side apart from these values that cos inverse of the value x, y and z can take. So having mentioned that, so I have made this point clear to you. So if cos inverse of x is equal to pi, then clearly I can write here as x is equal to cos pi, right? And also over here I can write y is equal to cos pi and z is equal to cos pi. But what is cos pi? Cos pi is -1. So you got x is equal to -1, y is equal to -1 and z is equal to -1. So I've got the value for x, value for y and value for z. Now let me take this as 2. So therefore 2 can be rewritten as x raised to the power of 2024. So -1 raised to the power of 2024. Why? Because x is found to be equal to -1, followed by -1 raised to the power of 2024, because y is raised to the power of 2024, followed by -1 raised to the power of 2024 positive 6 divided by -1 raised to the power of 2023 positive -1 raised to the power of 2023 positive -1 raised to the power of 2023. Now this is what? Odd quantity, odd number raised to the power of an even quantity, right? You got -1 raised to the power of 2. What are you going to get? You're going to get a +1, right? That is exactly what you have to place here. So this is going to be equal to +1, +1, +1, +6 divided by, this is a negative value, a negative quantity raised to the power of odd power. Say you got -1 raised to the power of 3. What do you get? You get -1. So that's exactly what you need to place here. So -1 followed by addition of -1 followed by addition of -1. So what is this equal to? 1 added with 1 added with 1 would give you 3, followed by +6 divided by -1 added with -1 followed by -1 gives you -3. 3 divides 6 2 times, so this is negative sign, so this is equal to negative 3 followed by a negative 2. So what is this? 3 negative 2 will give you 1. So this is the solution, and let's go to the choices. Now clearly you can see the right choice is already there waiting for us to be selected. So that's the end of the solution, students. So this is a nice problem, and we'll move on to the next question. Students, we have another beautiful question. The question is as follows: find the number of real roots for the equation tan inverse of square root of x times x positive 1 positive sine inverse of root of x squared positive x positive 1 is equal to pi over 4. Now we have been given choices. A, is it 1? B, is it 2? C, is it 4? D, is it 0? Now foremost, to get the solution, we must know where the function is defined. Right? In other words, we are looking for the domain of the function. Now clearly, tan inverse of root of x times x positive 1 is defined for all values for which x times x positive 1 is greater than or equal to 0. So this is necessary. If x times x positive 1 is greater than or equal to 0, then only tan inverse of square root of this quantity is going to be existing, right? Because it cannot fall short of 0. That's the smallest value that is allowed so that this function is existing. So this is one side. We got the other side. Now we know that the domain for sin x lies between negative 1 and positive 1, right? But in this case we are looking at root of x squared positive x positive 1. So that would mean if I were to place negative 1 less than or equal to root of x squared positive x positive 1 less than or equal to 1, there is a small adjustment we need to do, because clearly negative 1 cannot be an outcome for this. So the minimum value that root of x squared positive x positive 1 will produce will be 0. So we will have to rewrite this as 0 greater than or equal to square root of x squared positive x positive 1 less than or equal to 1. So this is what is the permitted domain for this quantity, sine inverse of root of x squared positive x positive 1. So we got two sides, right? So now what I would do is I would try to simplify and extract the value for x here. Now if I were to take root of x squared positive x positive 1 is less than or equal to 1 and square both sides, I would arrive at an inequality of this fashion. Now clearly I can get rid of this 1 on either side, and this would give me x squared positive x less than or equal to 0, right? So this is almost done. So let us move on to the other inequality. Now distributing x would give us x squared positive x greater than or equal to 0. So this is what I've got for this side. Now I've got an inequality here and I've got an inequality here. Now these two inequalities together have to be satisfied for this entire function to exist. So when would that be possible? On one side we got x squared positive x is greater than or equal to 0. On the other side we got x squared positive x is less than or equal to 0. Now to satisfy these two inequality would mean that there is exactly one particular point for which x squared positive x will be greater than or equal to 0 and x squared positive x will be less than or equal to 0, and that point would be x squared positive x equal to 0. Only at this particular point this inequality and this inequality will hold good. So having got that, let me just write it as x of x positive 1 is equal to 0. Clearly from here I write x is equal to 0, and then from here I write x is equal to negative 1. So those two values are obtained. Now what we need to do, we need to take this value and substitute it in this left side of this entire equation and find out if left hand side is equal to right hand side. So that is what we need to do. So let us just take x is equal to 0. Let me use this side of this space. X is equal to 0 and I substitute here. 0, 0, positive 1. So this is going to be 0. So tan inverse of 0 is going to give me 0. And 0, 0 and sine inverse of root 1, that is going to be sine inverse of 1. Let me write that down. Sine inverse of 1. And that should be equal to pi over 4. Now sine inverse of 1 is what? It's pi over 2. So we have something like this. Pi over 2 being equal to pi over 4. Is it possible? No, it's not possible. Right? Pi over 2 cannot be equal to pi over 4. Not possible. Right? We cannot even dream of such a situation. Right? That is the best way to state. So x is equal to 0 has to be dropped. It doesn't serve our purpose. Now let me take x is equal to negative 1. So this is the case 1. So probably case 2. Let me just go to case 2. X is equal to negative 1. So if we were to substitute x is equal to negative 1, this is going to become 0. So tan inverse of 0 will be 0. X is equal to negative 1, positive 1, they get cancelled. Negative 1. Again I am getting sine inverse of 1, which has to be equal to pi over 4. Sine inverse of 1 produces pi over 2. Again I need to have a justifiable statement here, because this is basically giving us a contradiction, pi over 2 being equal to pi over 4. So again this is not possible, and so x is equal to negative 1 should also be dropped. So what is the understanding? We are unable to find values of x such that the left hand side is equal to right hand side. So that would mean we are not able to find any real root at all. So ultimately the choice of selection should be D. So this is a beautiful question, students. I hope you enjoyed it. Let's move on to the next one. Students, now it's time for us to understand the properties of inverse trigonometric functions. Okay, so let's get it started. The first one, sine inverse of negative x is going to be equal to negative sine inverse of x. That's the first one. Now the second one is tan inverse of negative x is equal to negative tan inverse of x. And the third one, let me write this down here. Cosecant inverse of negative x is equal to negative cosecant inverse of x. Okay. Now you would remember, if f of negative x is equal to negative f of x, then we call f of x is an odd function. Alright, so what is the meaning of this? So this means sine inverse of x, tan inverse of x, and cosecant inverse of x, they are all odd functions. So let's go on to the next set. Fourth one, cos inverse of negative x is equal to pi negative cos inverse of x. Very important. Number 5, cot inverse of negative x is equal to pi negative cot inverse of x. Number 6, secant inverse of negative x is equal to pi negative of secant inverse of x. Right? So make sure to write these in the corner of your mind and move on, students. Now we got the second set of properties too. So they are as follows. Let me write it as 7. 7. You have a trigonometric quantity sine and then inverse trigonometric quantity sine inverse of x. When sine attacks sine inverse of x, outcome will be x such that x lies between negative 1 less than equal to x less than equal to 1. Number 8, cos inverse of x will be equal to x such that x lies between negative 1 and positive 1. Then number 9, tan inverse of x is equal to x such that x is element of real number. We already know this. Number 10, cot inverse of x is equal to x with x element of r. Then we got number 11, cosecant inverse of x is equal to x for which modulus of x is greater than or equal to 1. So the understanding for this is nothing but negative infinity followed by negative 1 union positive 1 comma infinity. So in other words, x is an element of this interval. So that is for cosec times of cosecant inverse of x. Now we got number 12. I'll write it down here. This is secant inverse of x is equal to x such that modulus of x is greater than or equal to 1. Okay, so that is the set for property 2. Now the next one is going to be property number 3. So here we actually have sine of sine inverse. So in property number 3, that's 13, is going to be, instead of having sine, we are going to have sine inverse of sine x. The outcome is also going to be the same x, but the function is actually defined for x contained in negative pi over 2 comma pi over 2. This is critical. Right, here it is negative 1 less than or equal to x less than or equal to 1. In this case it's negative pi over 2 comma pi over 2. So 14, this is going to be cos inverse of cos x, which will also be giving us x, and in this case x is contained in 0 comma pi. So we got cos, we got sine, now it's going to be tan. So tan inverse of x will be equal to x, and in this case x is contained in the open interval pi over 2 comma pi over 2. So after this we need to go on to cosecant. So 16, cosecant inverse of x will be equal to x. In this case x is contained in negative pi over 2 comma pi over 2, taking 0 away. Right, so in this case it's completely closed, in this case it's open, in this case it is closed with 0 being taken out. So we have already seen something similar to this in the earlier lesson. So this has a relationship with this, and subsequently this has a relationship with this. So I'm just showing you some technique to remember the x interval. So now coming to cos inverse have to be clubbed with cot. So this is number 17. So I've got cot inverse of cot x will also give me x, but apparently in this case this is closed, right? So x is going to be contained in open 0, pi. And then 18th one is going to be secant. So secant inverse of secant x will give me x, but with the x value being contained in 0, pi minus pi over 2. So we take away that value, pi over 2. So this is connected with this. This is closed, this is open, and subsequently it is connected to the final one, secant inverse of secant x, right? So this is some techniques to remember the x values interval. Now let's move on to property number 4. The first one is sine inverse of x added with cos inverse of x will give us pi over 2, with x lying between -1 and +1. Number 2 is tan inverse of x added with cot inverse of x will give us pi over 2, with x element of real numbers. Property 3 is cosecant inverse of x added with secant inverse of x will give us pi over 2, with modulus of x greater than equal to 1. Students, we are given a nice question, and this question appeared in 2001. So the question is as follows: if sine inverse of x squared negative x to the power of 4 divided by 3 positive x to the power of 6 over 9 etc. added with cos inverse of x to the power of 4 negative x raised to the power of 8 divided by 3 positive x raised to the power of 12 divided by 9 etc. is equal to pi over 2, such that 0 less than equal to modulus of x less than equal to root 3, strictly less than root 3, then the number of values of x is equal to, so we are given this equation, this added with this is equal to pi over 2, and the interval for modulus of x is given. Then we are expected to find all of those x's for which this equation holds good, and the number of such x's have to be found, as I mentioned to you, and the choices have to be placed there, right? Or I should say the choices have to be selected accordingly. So let me place those choices. So we have been given A to be as 1 and B is 2, C is 3 and D is 4. So let's start off. Now what I would like to do is I would like to use this particular property which we have seen. Now clearly I would like to draw your concentration and your focus to this particular property. Sine inverse of x positive cos inverse of x is equal to pi over 2. Over here we have this expression and then this expression. Now sine inverse of this quantity positive cos inverse of this quantity will be equal to pi over 2 only if these two quantities are equal. How do I know? According to the property. So this means this expression, right, let me just place a box there, should be equal to this expression. Now how am I going to get the expressions? So I would have to use the concept of geometric series. Now clearly this is a geometric series where the formula is a over 1 negative r. So we would use a over 1 negative r. A is the first term, so I can see that a's value for the first series is x squared, and the common ratio r is negative x squared over 3. So this is for the first series, and similarly for the next one, a over 1 negative r, the a term is x to the power of 4, that's the first term, and r is negative x to the power of 4 divided by 3. So if I were to substitute these values for the first quantity, I would get x squared divided by 1 negative of negative x to the power of 3 over, x to the power of 2 over 3 with a negative sign. So this can be simplified, and this has to be equal to the second quantity, which is x to the power of 4 divided by 1 negative of negative x to the power of 4 divided by 3. So if I were to simplify this, I would get x squared divided by 3 times, this is going to be positive x squared divided by 3, which can be flipped and rewritten as 3 times x squared divided by x squared positive 3. This has to be equal to, if I were to rewrite this, this is going to be 3 times x to the power of 4 divided by 3 positive x to the power of 4, right? So if I were to equate them, this is going to be 3x squared divided by x squared positive 3 is equal to 3x to the power of 4 divided by x to the power of 4 positive 3. Now you can cancel x squared, but if you're cancelling x squared, you will have to take x squared to be equal to 0. Now let me just simplify this and write this down here. So you have 3 times x squared times x to the power of 4 positive 3 is equal to 3 times x to the power of 4 times x squared positive 3. Now clearly x squared can be cancelled, 3 can be cancelled. So this is going to give me x to the power of 4 positive 3 is equal to x squared of x squared positive 3. This is what I have got. Now as I mentioned to you, I have cancelled x squared, so on the corner I will have to take x squared is equal to 0. So that is one system. Now we will have to solve this. So let me simplify this. This is going to be x to the power of 4 positive 3 is equal to x to the power of 4 positive 3 times x squared. Now this and this gets cancelled. So I now have 3 times x squared negative 3 is equal to 0. From here I can write 3 of x squared minus 1 is equal to 0. So this would mean x squared is equal to 1 and x is equal to positive 1, x is equal to negative 1. So over here x is equal to 0 is one value, and then next value x is equal to negative 1, and then x is equal to positive 1. So 3 values we have secured. So the choice is C. If you were to go back to the choices and check it out, C is the one which gives us 3. So there are 3 such values of x for which the given equation holds good. Students, this question was asked for JEE May 2021. It's a beautiful question. The question is as follows. If sine inverse of x raised to the power of 2 negative cos inverse of x raised to the power of 2 is equal to sum a, and that x lies between 0 and 1, with a not being equal to 0, then we are expected to find the value of 2 times x squared negative 1. And we have been given with choices. A, is it cos 4a over pi? B, is it sine 2a over pi? C, is it cos 2a over pi? And D, is it sine 4a over pi? So it's a lovely question. Now foremost, let me consider sine inverse of x raised to the power of 2 negative cos inverse of x raised to the power of 2 is equal to a. Now we know a formula, a squared negative b squared is equal to a negative b times a positive b. So by this formula, I can rewrite this as sine inverse of x negative cos inverse of x times sine inverse of x positive cos inverse of x, which is equal to a. But we know that sine inverse of x positive cos inverse of x is equal to pi over 2. I substitute that, I get sine inverse of x negative cos inverse of x times pi over 2 is equal to a. I push this 2 and pi down. So this is going to be 2a over pi. This is sine inverse of x negative cos inverse of x. Now since sine inverse of x positive cos inverse of x is equal to pi over 2, I can clearly write sine inverse of x to be equal to pi over 2 negative cos inverse of x. So I take this and I substitute here. So this is going to be pi over 2 negative cos inverse of x negative cos inverse of x is equal to 2a over pi. Now this is going to be equal to pi over 2 negative cos inverse of x added with cos inverse of x would give me negative 2 times cos inverse of x is equal to 2a over pi. Let me move this to the other end. So I get negative 2 times cos inverse of x is equal to 2a over pi negative pi over 2. And if I were to push this 2 down, in fact there's a negative sign, so I would have to get rid of the negative sign. So I can get rid of the negative sign as follows. So 2 times cos inverse of x. If I were to push this negative sign out and rearrange this, this is going to be as follows. So negative of pi over 2 positive, no, it's negative 2 times a divided by pi, right? And you have a negative sign here. So clearly what happens, this negative gets cancelled. So you have cos inverse of x being equal to pi over 2 negative 2a over pi divided by 2. And if you were to flip this up, this is 2 over 1, right? So this is going to be 1 over 2 times pi over 2 negative 2a over pi, which is nothing but pi over 4 negative a over pi, which is my cos inverse of x. So if I want to find x, so taking cos on both sides, this is going to give me x is equal to cos of pi over 4 negative a over pi, right? This is for x. But we are asked to find the value of 2 times x squared negative 1. So therefore 2 times x squared negative 1 is equal to 2 times of my cos value is, in fact my x value is cos of pi over 4 negative a over pi. This is squared, so this is going to be cos squared followed by negative 1. Now we know that 2 times cos squared theta negative 1 is cos 2 theta, right? Formula. So this can be rewritten as 2 times x squared negative 1 is equal to cos of 2 times of theta is this pi over 4 negative a over pi, right? If I push this 2 inside, this is going to give me cos of pi over 2 negative 2a over pi. Now this is nothing but cos of 90 negative theta. What is that? Sine theta. So this is going to be equal to sine 2a pi, right? So do we have sine 2a pi? It's right over here, sine 2a over pi. So there's a beautiful question, students. Students, let's do another question. This question was asked in JEE Means 2021. This is a beautiful question. Let me just write that question down. If sine inverse of x over a is equal to cos inverse of x over b is equal to tan inverse of y over c, with this x lying between 0 and 1, we are asked to find cos of pi c over a positive b, right? This is required. So the choices, let me write down the choices. A is it 1 negative y squared over 2y, b is it 1 negative y squared over 1 positive y squared, c is it 1 negative y squared, and d is it 1 negative y squared over y times the root of y. So this is an interesting question. Now we have studied a law in ratio and propositions. Suppose you got a over b is equal to c over d is equal to e over f, then this means a positive c divided by b positive d is equal to e over f. Let me give you an illustration. 1 over 2 is equal to, say, 2 over 4 is equal to 3 over 6, then clearly 1 positive 2 divided by 2 positive 4 will be equal to 3 over 6. So I would be using the same property, right? So let me just box this up. Now using this same property, I can rewrite the given question as sine inverse of x positive cos inverse of x divided by a positive b is equal to tan inverse of y divided by c. Fine. But we know that sine inverse of x positive cos inverse of x is equal to pi over 2, right? So take this and substitute it here. So this would mean pi over 2, that's nothing but pi over 2 times of a positive b is equal to tan inverse of y divided by c. So let me push this c to that side so that I can get pi c. So this would mean I have pi c divided by, I don't want this 2 here, let me push the 2 to the other side and just retain a positive b. So this is going to be 2 times of tan inverse of y. Now we need cos, so let me use the space here. So I'm applying cos, so it's going to be cos of pi c divided by a positive b is equal to cos of 2 times of tan inverse of y. Now let me take tan inverse of y is equal to theta. So this means y is equal to tan theta. So therefore I can write cos of 2 times of tan inverse of y as cos of 2 theta. Now what is cos of 2 theta? Which is, this is equal to 1 minus tan square theta divided by 1 positive tan square theta. But what is tan theta? Tan theta is y, so it's going to be 1 negative y squared divided by 1 positive y squared, which is nothing but our cos of pi c over a positive b, right? But where is this? Let us go back to the choice and see. You see that? 1 negative y squared divided by 1 positive y squared. That's the solution for this question. Welcome students, we are starting with the property 5 and these are the following properties. We got cosecant inverse of x is equal to sine inverse of 1 over x, and this is valid only when modulus of x is greater than or equal to 1. Number 2, secant inverse of x is equal to cos inverse of 1 over x, and this is valid for modulus of x greater than or equal to 1. And the third one, sine inverse of x is equal to cosecant inverse of 1 over x, and clearly in this case x cannot be equal to 0 and modulus of x is less than or equal to 1. Number 4, cos inverse of x is equal to secant inverse of 1 over x. Clearly x is not equal to 0 and modulus of x is less than or equal to 1. Number 5, cot inverse of x is equal to tan inverse of 1 over x. Clearly x is greater than 0, and subsequently when x is less than 0, the formula takes the shape of pi positive tan inverse of 1 over x, right? So these are the important properties that we will have to know, and having given this, let us head on to do the questions. Now we got something very important, that is property number 6. So that is tan inverse of x positive tan inverse of y is equal to tan inverse of x positive y over 1 negative x into y. This occurs if x times y is less than 1. Now there is also another formula for this, and this would occur when x is greater than 0 and y is greater than 0 and x times y is greater than 1, right? So in this case it is x and y is less than 1, in this case x and y are greater than 1, and x and y are positive here. You see that x is greater than 0, y is greater than 0, and the another variation is going to be negative pi positive tan inverse of x positive y over 1 negative x times y, and in this case x is less than 0, y is less than 0, and x and y is greater than 1. So we got 3 variations, and it is imperative that you remember all this, right? Now heading on to number 7, tan inverse of x negative tan inverse of y is equal to tan inverse of x negative y over 1 positive x times y. This is possible when x is greater than 0 and y is greater than 0, right? Now there is the other one, so we got 2 formulae for this, 1 and 2. So this is going to be 2 times tan inverse of x is equal to tan inverse of 2x over 1 negative x squared, right? So having given you all this, the suggestion that I would like to place here is make sure that you write all of this in the corner of your mind. Now I would like to give you a note here. It's important that you know this note, which is tan inverse of 1 added with tan inverse of 2 added with tan inverse of 3 is equal to pi. Now the next one is tan inverse of 1 added with tan inverse of 1 over 2 added with tan inverse of 1 over 3 is equal to pi over 2. So let me show you the proof for this particular property. Now let me consider tan inverse of 1 added with tan inverse of 2 added with tan inverse of 3. Now this is equal to tan inverse of 1 is pi divided by 4 positive tan inverse of 2 added with tan inverse of 3. Now if I were to take x is equal to 2 and y is equal to 3 and find out x into y, I get 2 into 3, which is 6 greater than 1. This is going to be equal to pi over 4 positive pi positive tan inverse of 2 added with 3 divided by 1 negative 2 times 3. So this is the formula I have used. Okay. So this is equal to pi over 4 positive pi positive tan inverse of 5 divided by 1 negative 2 times 3 is 6. That's going to give me negative 5. I cancel this. I get pi over 4 positive pi. I can take the negative out, so it's going to be negative tan inverse of 1. What is tan inverse of 1? Pi over 4. So pi over 4 can be cancelled, giving me pi, which is equal to the right hand side. Right, so hence proved. So now what I wish to do is I would like to show you this proof. So now I would like to show you tan inverse of 1 positive tan inverse of 1 over 2 positive tan inverse of 1 over 3 is equal to pi over 2. So let me consider the left hand side, which is tan inverse of 1 added with tan inverse of 1 over 2 added with tan inverse of 1 over 3. Now tan inverse of 1 is pi over 4. I'm going to group this together and rewrite this as tan inverse of 1 over 2 positive tan inverse of 1 over 3. Now if I were to take x is equal to 1 over 2 and y is equal to 1 over 3, then x times y is 1 over 2 times 1 over 3, which is equal to 1 over 6, which is strictly less than 1. Now when this happens, we will use tan inverse of x positive tan inverse of y, which is equal to tan inverse of x positive y divided by 1 negative x into y. So this is a formula. Why do we use this? Since x into y is less than 1, because of this. So this is going to be rewritten as pi over 4 positive tan inverse of, in place of x I've got 1 over 2, so it's going to be 1 over 2 positive 1 over 3 divided by 1 negative 1 over 2 times 1 over 3. So which is equal to pi over 4 positive tan inverse of, this is going to be 6, 3 and 2 divided by 1 negative 1 over 6, which can be rewritten as pi over 4 positive tan inverse of 3 and 2, 5 divided by 6. This is 6 negative 1, 5 divided by 6. So if you were to flip it, I get pi over 4 positive tan inverse of 5 over 6 times 6 over 5. So 6 gets cancelled, 5 gets cancelled, giving me pi over 4 positive tan inverse of pi. It's actually tan inverse of 1. Right? So which is nothing but pi over 4 positive. Tan inverse of 1 is nothing but pi over 4. Taking LCM as 4, I get pi positive pi, which is 2 pi over 4, which is equal to pi over 2. What is pi over 2? This is exactly what is present in the right hand side. So this is equal to right hand side, hence the proof. Right? We are given the following question, students. The value of tan of 2 times tan inverse of 3 over 5 positive sine inverse of 5 over 13 is equal to what? We are given the following choices: negative 181.69, B 220 divided by 21, C negative 291 divided by 76, D 151 divided by 63. So foremost, let me start off by considering the given question. I would not be taking in this tan. I would just first considering only the quantity inside the parenthesis. So that is 2 times tan inverse of 3 over 5 positive sine inverse of 5 over 13. Now if I were to take sine inverse of 5 over 13 to be as theta, therefore I have sine theta is to be equal to 5 over 13. So let me draw that theta. This is 5 over 13. So opposite side is 5. This is 13. If I were to take this as ABC, AB squared positive BC squared is equal to AC squared. I need AB squared. So that's going to be AC squared negative BC squared. AC squared is 13 squared and BC squared is 25. So clearly AB is going to be 12, right? So this is 12 units, so I have placed it there. Now from here I have to get tan theta. Now tan theta, therefore tan theta is equal to 5 over 12 and theta is equal to tan inverse of 5 over 12. Right, so that is a value that we have got. So what I would like to do is I would have to utilize, in place of theta, I would like to utilize this value, right? Because this is actually taken to be a sine inverse of 5 over 13 to be equal to theta. So in place of this quantity, I can very well substitute this quantity, right? Because this is also another representation for theta. So let me do that. So this is equal to 2 times tan inverse of 3 over 5 positive tan inverse of 5 over 12. Okay, we've got that. So now I would like to utilize a formula. So let me show you the formula. Now 2 times tan inverse of x is equal to tan inverse of 2x divided by 1 negative x squared. So this is a formula that I would be utilizing over here. So this is equal to tan inverse of 2 times of, in place of x we got 3 over 5 divided by 1 negative 3 over 5 raised to the power of 2 positive tan inverse of 5 over 12. So this is equal to tan inverse of, now let me perform the simplification. This is 3 times 2 is 6 over 5 divided by 9 over 25. So if I were to take the LCM, this is going to be 25 negative 9 divided by 25. So that is going to be 16 over 25. Right? So if I were to place 16 over 25 over here, and then it would require further simplification. So this is added with 5 tan inverse of 5 over 12. Okay. Now if you were to flip this, this is going to be tan inverse of 6 over 5 times 25 over 16. 5 divides here 5 times, 2 divides here 3 times, and 2 divides here 8 times, plus tan inverse of 5 over 12. So this is equal to tan inverse of 3 into 5, 15 divided by 8 plus tan inverse of 5 over 12. Okay, these two terms are there. So now what I wish to do is I would like to apply the formula again. So let's do that. So before you could do that, find the value of x times y. Now x is 15 over 8 and my y is 5 over 12. This is going to be 5 as a 25 to 75 divided by 2 to the 16 196. Now this is clearly less than 1, right? So we can apply the formula, the relevant formula when it is less than. So this is the formula when x times y is less than 1. So this will be the formula that we will be using. So let's do that. So this is equal to tan inverse of 15 over 8 added with 5 over 12 divided by 1 negative 15 over 8 multiplied with 5 over 12, right? So we will have to apply some simplification. So let's do that. So if I were to use this space here, I will simplify taking 15 over 8 positive 5 over 12. So if I were to take the LCM as 24, right? 8 divides here 3 times, 8 divides 24 3 times. So 3 times 15 is 45, positive 2 times, 5 times 2 is 10, not 30, 5 times 2 is 10. So I'm getting a value of 55 divided by 24 for this quantity. So if I were to simplify this quantity, this is 75 over 96. So you will get 96 minus 75 divided by 96. So you get 96 minus 75. This is going to give you 21. This is going to give me 21 over 96. So if you were to flip this is actually going to be 55 over 24, and you flip it, you get 96 over 21. This is what you're getting. So you will have to make some simplification. 4 4s are 16, 1 4 2s are 8, 9. So this one divides here 4 times, and multiplying this, 5 4s are 22, 5 4s are 20, 21, 22. 220 divided by 21. So this is equal to tan inverse of 220 divided by 21. Now you would have remembered that when I started, I said I'm not going to use this tan at all. Okay, so I have reserved this tan for the conclusion. So applying that tan, this is going to be tan inverse of 220 divided by 21. So what happens here? Tan inverse gets cancelled, giving me 220 divided by 21. So this is the final solution. So let's go check it out if that solution is occurring elsewhere. So clearly you see that 220 divided by 21. That is the exact solution. So this is a lovely problem to practice, students. We will move on to the next question. Let's do this question, students. It's a lovely question. We've been given cosecant of 2 times of cot inverse of 5 added with cos inverse of 4 over 5, and we are expected to find the value. So what exactly is this value? So we have 4 choices. First choice is 75 over 56. Choice B is 65 over 56. C is 56 over 33, and D is 65 over 33. So we've got the following 4 choices. So foremost, as I mentioned to you, I wouldn't be taking cosecant into the first level of consideration. So I would just take in the quantity within the parenthesis. So let me just start off by stating, consider 2 times cot inverse of 5 added with cos inverse of 4 over 5. Now let me just take cos inverse of 4 over 5 to be equal to theta. Therefore cos theta cos theta is going to be equal to 4 over 5. So if you were to take the triangle, so this is going to be 4 and 5, ABC. So AB squared BC squared is equal to 16. I don't have BC squared, but AC squared is 25. So 25 negative 16 is equal to BC squared. This is going to give me 9. So BC is equal to 3. Right? So what I wish to do is I would like to, in fact, I would have to convert this into tan. So this also have to be converted into tan. Right? So let me do that. So foremost, this is nothing but 2 times. We have a formula for cot inverse of x. Cot inverse of x is nothing but tan inverse of 1 over 5. Right? So this is already converted. Added to this, I need to have a tan here. Now from this, if I were to write tan theta is going to be 3 over 4. Therefore theta is equal to tan inverse of 3 over 4. This is what I've got. So just substitute that value. Theta is tan inverse of 3 over 4. So I've got 2 times of tan inverse of 1 over 5. In other words, I'm going to use the formula 2 times of tan inverse of x formula, which is equal to tan inverse of 2x divided by 1 negative x squared. We've already used this formula in the previous question. So this is going to be equal to tan inverse of 2 times of my x is 1 over 5 divided by 1 negative 1 over 5, that's going to be 1 over 5 square, that's going to be 25, right? So this is what I have got for the first quantity. Added with the second quantity, I'm going to retain it as it is, tan inverse of 3 over 4. Now I can simplify this. This is going to be equal to tan inverse of 2 over 5, 24 over 25, right? So when I flip it, I will be getting 25 over 24. So 5 divides here 5 times, 2 divides here 12 times. Of course there is tan inverse of 3 over 4. So if you were to write this, this is going to be tan inverse of 5 over 12 added with tan inverse of 3 over 4. Now clearly x and y will be less than 1. So thereby we can use this formula, tan inverse of x positive y divided by 1 negative x times y. So we can use this formula. Right? So this is nothing but tan inverse of x positive tan inverse of y. So applying this formula, this is going to be equal to tan inverse of 5 over 12 added with 3 over 4 divided by 1 negative 5 over 12 times 3 over 4. So this is equal to tan inverse of, I take the LCM as 12. This is 5 positive 3 3s are 9 divided by, this is 48 negative 15 divided by 48. You got 48 and you got to take away 15. So this is going to be 3 and 3, 33, right? So let me write that down. So this is equal to tan inverse of 9 added with 5 will give me 14 divided by 12. This is going to be 33 divided by 48. So you flip it, you get tan inverse of 14 over 12 times 48 over 33. So 12 divides here 4 times. 4 4s are 16. 1 4s are 4 5. So 56 over 33. So therefore, look at the question. The question wants us to get cosecant of the quantity. So this is equal to cosecant of tan inverse of 56 over 33, right? Now let me just let tan inverse of 56 over 33 be equal to theta. So that means tan theta is equal to 56 over 33. So let me draw the triangle, right triangle. So 56 divided by 33. So this is A, B, C. I want AC. So AC squared is equal to AB squared positive BC squared. This is 3 squared positive 5 6 squared. So let me multiply that. So 9 9 9 9 9 18 1 1 0 8 9. This is one value. Now 56 into 56, 36 3 30 33 33 25 28 6 3 11 and 3. So I need to add 1089 with 3136. So what do I get? I get 15 1 9 12 1 2 and 4, right? So 4 2 2 5. So I need to get the square root of this. So what is the square root of this? Can I have this as to be equal to 65? Let me check out if 65 is the square root of this quantity, right? Of course, all these things are in the working side, right? Because my aim is to convert this into cosecant, so that's my approach. So if you were to multiply 65 into 65, 5 is 25, 2, 30, 32, 33, 36, 39, 5 and a 2 and a 2, yeah, 4 2 2 5, root of this is 65. So I got 65. Now let me take cosecant. Now cosecant theta is nothing but 1 over sine theta, right? So let me get the value for sine theta. So what is sine theta? From here, sine theta is equal to 56 divided by 65. So this means cosecant theta is equal to 65 over 56. So we are looking for theta. So therefore theta is cosecant inverse of 65 over 56, right? Now this is theta. So go and substitute here. So of course all of this thing is shown for your working. So if I were to take it as 2, let me give, therefore 2 becomes what? Cosecant inverse of 65 over 56. Cosecant inverse gets cancelled, giving me 65 over 56. So is there a solution for that? Is there a solution among the choices? Let's see that. Let's see if we have got it. Yes, we have got it. Can you see this? Choice B, 65 over 56. Okay, so that is the solution. You see that? We got that. So that's a nice bit of working we have, students. We'll move on to the next question. So students, now we got property number 7. This is for sine inverse of x added with sine inverse of y is equal to sine inverse of x times root of 1 negative y squared added with y times root of 1 negative x squared. If x is greater than or equal to 0, y greater than or equal to 0, and x squared positive y squared is less than or equal to 1. Right? So this is the formula. Let me reiterate the formula. Sine inverse of x added with sine inverse of y is equal to sine inverse of x times root of 1 negative y squared positive y times root of 1 negative x squared. If x is greater than or equal to 0 and y is greater than or equal to 0, followed by x squared positive y squared is less than or equal to 1. Now there is another alternation, or I should say another deviation to this, and that is given as follows: pi negative sine inverse of x times root of 1 negative y squared positive y times root of 1 negative x squared if x is greater than equal to 0, y is greater than equal to 0. In this case, x squared positive y squared is greater than 1. Over here it's less than equal to 1, but over here x squared positive y squared is greater than 1, strictly greater than 1. So this is quite a bit, and we will use this to solve questions. Now moving on, we got a formula for sine inverse of x followed by negative sine inverse of y, and that is going to be equal to sine inverse of x times root of 1 negative y squared followed by a negative sign, y times root of 1 negative x squared, with x and y being greater than 0. So in this case it was positive, in this case it is negative. Now subsequently there is also a formula for cos inverse of x plus cos inverse of y. Now this goes for plus and minus, or I should say plus or minus. So the formula is cos inverse of xy minus plus root of 1 negative x squared times root of 1 negative y squared, with x is greater than 0, y is greater than 0, and x is less than y. So make sure that you are able to write all of these formulae in your mind. We have a beautiful question here, students. The question is as follows: if cos inverse of x negative cos inverse of y over 2 is equal to alpha, then we are expected to find 4 times x squared negative 4 times xy cos alpha positive y squared is equal to what? Now we have been given the following choices. A, is it 2 times sine 2 alpha? B, is it 4? C, is it 4 times sine squared alpha? And D, is it negative 4 times sine squared alpha? So we are expected to select the right choice. So foremost, what I wish to do is I would like to consider cos inverse of x negative cos inverse of y over 2 is equal to alpha. Now clearly we can use this formula here, but the only thing is that instead of starting with a positive sign, we got a negative sign. So that would mean the outcome will get reversed. If we start with positive, we will have to end up with negative, but here we are starting with negative, so we will have to have a positive sign there. So applying the formula, so this is going to be cos inverse of x into y. So this is my first term, this is my second term, so it's going to be x times y over 2, and then followed by a positive sign. Now square root of 1 negative x squared times square root of 1 negative y squared divided by 4, because you are squaring this, right? So you got y over 2, so this is going to be y squared over 4, and the square root is actually flowing all through, and this is equal to alpha, okay? So let me move this cos inverse to the other end. So if I were to do that, this is going to be xy over 2 positive root of 1 negative x squared and root of 1 negative y squared over 4 is equal to cos alpha. Let me move this cos alpha to this side. This is going to be xy over 2 negative cos alpha. Let me move this to the other side. So this is going to be negative root of 1 negative x squared times 1 negative y squared over 4. I'm going to square this both sides. So if I were to square this, I would get xy raised to the power of 2, right? Divided by 2 raised to the power of 2. So this is going to be x squared y squared divided by 4 negative 2 times xy times cos alpha divided by 2 positive cos squared alpha. If I were to square this, the negative sign will become positive. I will get 1 negative x squared, the square root gets neutralized, times 1 negative y squared divided by 4. So let me remove the parenthesis. This would give me 1 negative y squared divided by 4, and then negative x squared, and then positive x squared y squared divided by 4. Right? Now clearly x squared y squared divided by 4, x squared y squared divided by 4, they'll get cancelled, and 2 and 2 gets cancelled, giving me negative xy cos alpha positive cos squared alpha is equal to 1 negative y squared over 4 negative x squared. Now if I were to multiply by 4, I would get 4 times xy with a negative sign cos alpha positive 4 times cos squared alpha is equal to 4 negative y squared negative 4 times x squared. Now the question wants us to find 4x squared 4xy cos alpha positive y squared. So let me move this and this to this side and move this to the other side. So this is going to be y squared positive 4 times x squared negative 4 times xy cos alpha is equal to 4 negative 4 times cos squared alpha. You can just make a check here. You see that 4 times x squared negative 4xy cos alpha positive y squared. This is exactly what we've got here, right? We want to know the value of this. If I were to take 4 out, I will get 1 negative cos squared alpha. 1 negative cos squared alpha is nothing but sin squared alpha. So this is going to be 4 times sin squared alpha, which is nothing but 4 sin squared alpha. So let's go back to the solution and check if our choice is featuring there, or our answer is featuring there as one of these choices. Now clearly you can see that 4 times sin squared alpha is present, so this is the right answer. So that's a beautiful question, students. I hope you understood this question. So the underlining point here is whenever you are encountering a square root, make sure to push the square root to the other side of the equal to sign, and that is a technique to solve this. And once you get that, the solution is simply follows, and it wouldn't be a difficult hurdle, or I would say a difficult process. It would not be erecting any challenges. So once you push the square root term to the other side, everything would just be a cakewalk. We've been given this question, student. This is another beautiful question. Let capital M and lowercase m be the maximum and minimum values of the function f of x is equal to tan inverse of sin x positive cos x, the values for which, or I should say the interval in which x lies, is given as 0, pi over 2 respectively, right? Then the value of tan of capital M minus lowercase m is equal to what? So this is the question, and we expected to solve this. So foremost, what I wish to do is, let me consider the function. Consider f of x is equal to tan inverse of sin x positive cos x. So now what I wish to do is, I would like to multiply by root 2 and divide by root 2. Alright, something of this fashion. Positive root 2 times 1 over root 2 times cos x. But this can be rewritten as, this is equal to tan inverse of I can take root 2 out and I can club this quantity alone. Root 2 I can take it out. So if I were to club this, with root 2 being taken out, this is nothing but sine of x positive pi over 4. You have to expand this, you will get this. Right? This, and this. Okay, fine. Now, this function is valid for 0 less than x less than equal to pi over 2. It's given in the question. So this function will be valid for 0 less than equal to x positive pi over 4. Okay, so we need to make a slight change. So what I would do is, instead of going up like this, I will just generate the interval from here, right? 0 less than equal to x less than equal to pi over 2. So I've got a pi over 4 here. So what I will do is I will add pi over 4, pi over 4 and pi over 4. So this is going to be the interval for which this function exists, is going to be pi over 4 less than equal to x positive pi over 4 less than equal to 3 pi over 4, right? So that is nice. And what we will have to do is, we will have to now draw the function, or I should say graph the function, right? Specifically, we will want to know the graph of this function, and once we are able to draw the graph and find out how the function is varying when this argument is lying between pi over 4 and 3 pi over 4, that would sufficiently be enough for us to get the maximum and the minimum values. So having stated that, let us do that. So I have come to a new page. So we have got f of x to be equal to tan inverse of root of 2 times sine of x positive pi over 4. We've got this, and the argument is valid for this interval, pi over 4 less than equal to x positive pi over 4 less than equal to 3 pi over 4, right? So now if I were to connect the interval with the graph, this is actually the graph of sine x, right? Of course, I'm not moving up. I'm just considering this space 0 to pi, right? Now, for this function, the argument lies between pi over 4 and 3 pi over 4. So if this is pi over 4 and this is 3 pi over 4, this is the point that we are looking for, right? Now, clearly this would correspond to 1 over root 2. If you were to take the values, you would end up with 1 over root 2. But we are interested in the maximum point. Now this maximum point for sine occurs at 1. So we are actually looking at a function which is actually existing between these 2 points, pi over 4 and 3 pi over 4, and their subsequent corresponding value is 1 over root 2, right? So this is what we have got from the interval. But apparently we would want to get the maximum and the minimum. So clearly the maximum is over here, the minimum is over here. So I can clearly rewrite this as 1 over root 2 less than equal to sine of x positive pi over 4 less than equal to 1, right? So this can be further rewritten as 1 less than equal to root 2 sine of x positive pi over 4 less than equal to root of 2. But what is this? Let me just take tan inverse throughout, because that is exactly what we are looking for. So this is going to be tan inverse of 1 less than equal to tan inverse of root of 2 sine of x positive pi over 4 less than equal to tan inverse of root 2. Now clearly we got m to be equal to tan inverse of 1 and capital M to be equal to tan inverse of root 2. So therefore we expect to find tan of capital M minus lowercase m, which is equal to tan of tan inverse of root 2 minus tan inverse of 1. Applying the formula, this is going to be tan of, so this would give me tan inverse of root of 2 negative 1 divided by 1 positive root of 2 times 1. Right, we have already seen this formula. You can just refer the formula. So clearly what happens, tan and tan inverse will be neutralized, giving me root 2 negative 1 divided by 1 positive root 2. So we can always rationalize. So we have this quantity, root of 2 minus 1 divided by root of 2 positive 1. I will multiply the numerator and denominator by root of 2 negative 1 divided by root of 2 negative 1. This is going to give me root of 2 negative 1 raised to the power of 2 divided by 2 negative 1. If I were to expand this, this is going to be 2 negative 2 times root 2 positive 1 divided by 1. 2 added with 1 will give me 3 negative 2 times root 2. So this will be the solution, students, and we'll move on to the next question. Welcome, students. We are being given this question. This question was asked in JEE Mains 2021. So the question is as follows: if 0 less than a and b is less than b, and we have tan inverse of a plus tan inverse of b to be equal to pi over 4, then we expected to find the value of the series. Then the value of a positive b negative a squared positive b squared over 2 positive a cubed positive b cubed over 3 negative a power 4 positive b power 4 divided by 4 plus etc. is equal to what? So we have the following choices. Let me write the choices. A log 2 to the base e, b log e over 2 to the base e, c e d e squared negative 1. Okay, so foremost, before we could start off, I would like to draw your attention to this log of 1 positive x series, which is nothing but x negative x squared over 2 positive x to the power of 3 over 3 negative x to the power of 4 over 4 plus etc. Now this is the series expansion for log of 1 positive x, which we would be utilizing. So having got this, let us now consider the given problem. So we have tan inverse of a positive tan inverse of b is equal to pi over 4. Now applying the formula, we would get this to be equal to tan inverse of a positive b over 1 negative ab is equal to pi over 4. Now if I were to move tan inverse to the other side, this would give me a positive b over 1 negative ab is equal to tan pi over 4, which is equal to 1. So I can now rewrite this as a positive b divided by 1 negative ab is equal to 1, which means a positive b is equal to 1 negative ab. I move this negative ab to the other side. I get 1 positive b. Positive ab is equal to 1. This is a very important equation which would come in very much handy. So having got this, let me just consider the given series. Let us now consider I'm taking it as S is equal to a positive b negative a squared positive b squared over 2 positive a raised to the power of 3 positive b raised to the power of 3 over 3 negative 8 power 4 positive b power 4 divided by 4 plus etc. Right? Now I wish to take all the a terms together. So a negative a squared over 2 first term, and then positive a cubed over 3, and then negative a power 4 over 4 plus etc. This is one part of the series, and then followed by b negative b squared over 2 positive b power 3 over 3 negative b raised to the power of 4 over 4 plus etc. This is the next part. Now what is this? This is nothing but the expansion for log of 1 positive x. So this is going to be equal to log of 1 positive a positive log of 1 positive b. Please remember, when I don't specify, we are actually taking log to the base e. So this is equal to log of 1 positive a times 1 positive b, right? And this is to the base e. So this is what we have got, and we will have to perform some simplification to extract the solution. So now what I wish to do is I would like to distribute the quantities 1 positive a times 1 positive b. So that would give me log of 1 into 1 positive b positive a positive ab to the base e. Now let me rewrite this as log of 1 positive a positive b positive ab to the base e. Now a positive b positive ab is equal to 1. We have already got that. So that means I can substitute it and rewrite this as 1 positive 1 to the base e, which is equal to log 2 to the base e. Now what is this? This is the solution, final solution. So does the solution feature among the choices? Clearly you can see that log 2 to the base e is present. So this is the correct solution for this question. So it's a lovely question, students, and we will move on to the next question. Students, this next question occurred in JEE Main 2020. So let me place that question here for you all. So we are given that y is equal to sigma k is equal to 1 to 6 k times cos inverse of 3 over 5 times cos kx negative 4 over 5 times sin kx, and we are expected to find dy over dx at x is equal to 0. Now foremost, what we have to observe here is, for this particular series, k varies from 1 to 6. In other words, k is the variable, x is a constant. So have that in mind. So what I wish to do is, I would like to take let cos phi b equal to 3 over 5 and sine 5 is equal to 4 over 5. So assuming this, I'm going to rewrite this series. Hence the series is rewritten as follows. So y is equal to sigma k is equal to 1 to 6 k times cos inverse of, this is cos phi times cos kx negative sine phi sine k times x. But we know that cos of A positive b is equal to cos A cos b negative sine A sine b, right? Substitute that. So that's going to be cos of, I'm going to write this as kx positive 5. It doesn't matter whether you write it as A positive b or b positive A, but I would like to write it as cos of kx positive 5. And this is product multiplied with k times cos inverse, right? So place the parenthesis and sigma k is equal to 1 to 6 with y equal to. So cos inverse and cos, they get cancelled, giving me this is equal to k is equal to 1 to 6 k times of k times x positive 5. Now I can multiply this. This is going to be equal to sigma k is equal to 1 to 6 k squared x positive k times 5. I can further rewrite it as sigma k is equal to 1 to 6 of k squared times x positive sigma k is equal to 1 to 6 of k5. I can take k squared out, not k squared, x out, because k is a variable. X times sigma k is equal to 1 to 6 k squared. I can take 5 out. Sigma k is equal to 1 to 6 times k. Now what is this? This is summing up k squared terms from 1 to 6. So we got a formula, right? So what is the formula? That formula is written as follows. For example, instead of k you got n, and you are basically summing up n squared terms. Then the formula is going to be n into n positive 1 times 2n positive 1 divided by 6. This is the formula. So using that formula, this is going to be x of k times k positive 1 times 2k positive 1 divided by 6, right? So that's fine. So this is actually summing up, let me write this down over here. This is going to be sigma of n, which is nothing but n into n positive 1 divided by 2. So this is going to be 5 times of k into k positive 1 divided by 2. So we got these two terms, and we will have to take the values, right? We will have to take the values and place in for k, right? That's exactly what we're going to do. So this is going to be x into, the terms are 1 to 6, so substituting k is equal to 6, you get 6, 7 times 6 to the 12 positive 1, 13 divided by 6 positive k is equal to 6. This is going to be 5 times 6 of 7 divided by 2. So 2 divides 6 3 times, and 6 and 6 can be cancelled. So this is going to be x times 7 times 3 is 7 3 is 21 to 91. So you got 91 there. Positive 3 times 5. So 3 times 5 you can write it as some k dash. So this is equal to y. But we are expected to find dy over dx. dy over dx. So therefore dy over dx, differentiating the right hand side with reference to x, we get this to be equal to 91. This is constant. This gets vanished. So this is the final solution. Right, this is a lovely question, students, and we'll move on to the next one. Students, this is the new chapter, summation of series, and it is also a very important chapter. Now we have been given a question. We are expected to prove that tan inverse of x over 1 positive 1 times 2 of, or I should say 2 times x squared positive tan inverse of x over 1 positive 2 times 3 times x squared positive tan inverse of x over 1 positive 3 times 4 of x to the power of 3 plus etc. And the nth term is tan inverse of x over 1 positive n into n positive 1 times x squared. Now we are expected to show this is equal to tan inverse of n positive 1 times x negative tan inverse of x, right? So foremost, what we will have to do, this consists of 3 steps. The first step is write the general term. Write the general term. Okay, say for example, for some tr, t suffix r. So how are we going to write the general term? So this is going to contain tan inverse, obviously. Now if you were to observe the numerator, it has got x, 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 and x follows up until the last term or the nth term. So we should have an x, and then you got 1, 1, 1, 1, 1. So it has to have 1, and then you got a 1 here, and then it becomes 2, and then 3, and then etc. it goes up. So we are starting with some n, right? N into n plus 1. So in this case it's just for some term r, so I would place r here, and then that has to be multiplied with 1 is incremented here, that is 1, the value is incremented by unit 1. So we start here as 2, and then it becomes 3, and then 4. So it's going to be 1, and instantaneously you got 1 plus 1, that's 2, and then 2 and 3 and 3 and 4 and so on and so forth. So this is going to be, we start with r, and then there is an increment of 1, so it's going to be r plus 1. That's fine. So the next term is x squared, x squared, x squared, x squared, x squared. X squared seems to be occurring all through, so I just place x squared, that's it. And this value of r starts from r is equal to 1 and it moves up to n, right? So for r is equal to n, we can generate the nth term, so that is fine. Now having got this, what we will do is we will use the following formula. What is that? Tan inverse of x negative y divided by 1 positive x times y. Now you might be asking, why am I using this formula? Because this formula gives me tan inverse of x negative tan inverse of y, and that is exactly what is required here. The only thing is that we got n positive 1 there. That is the reason I'm using this formula. Now the question comes, how am I going to write this to represent this? Only then I can use this, right? So what I would do is I would want to write this as a component of 2 terms. So let me just fix the denominator. Now in denominator I got a x squared. I want to split that x squared into 2 x's and then push 1 x over here. So let this be 1 positive r times x of r positive 1 times x. So this is for the denominator. Now I got to x there, let me place that x, and then I have got tan inverse. So tan inverse, I'm placing it here. Right, so of course there is a sigma there. Sigma r is equal to 1 to n. Now this term I would have to take the x inside, so this is going to be sigma r is equal to 1 to n tan inverse of x over 1 positive r times x times rx positive x. And then I'm going to write it in this fashion. So sigma r is equal to 1 to n tan inverse of, so I'll start with this quantity, let this be my x. So rx positive x, this is my x followed by my y rx. So in that case it's fair enough. So it's going to be 1 positive r times x positive x times rx. Though in the case of multiplication it doesn't matter whether we write this first or this first, right? But when we are summing up, it is imperative that we are very much worried about, or I should say we need to be much concerned about the order in which we represent the quantities, because of the fact that there is a positive sign here. Now clearly this representation would give me a positive sign. Okay, so I have got tan inverse of x negative y divided by 1 positive x into y. So now I can replace this. So this is equal to, this entire thing is going to be replaced by this. So sigma r is equal to 1 to n tan inverse of, this is my x, so it's going to be rx positive x negative, and this is my y, so tan inverse of rx. Fair enough. So the parenthesis goes like this. So this looks nice, but the only thing is that we will have to sum the quantities up. So r varies from 1 to n. So let us start the values of r. R is equal to 1. I get tan inverse of x positive x, r is equal to 1 followed by tan inverse of x, and then added with r is equal to 2, so tan inverse of 2x positive x negative tan inverse of 2x, r is equal to 3 positive tan inverse of 3x positive x negative tan inverse of 3x, and so on, and finally it goes up. Finally you will have r is equal to n, so tan inverse of n times x positive x negative tan inverse of nx. Now clearly if you see here, this is x positive x, right? That's going to be 2x. So positive 2x and negative 2x. When I say positive 2x, I mean tan inverse of 2x with a positive sign followed by negative tan inverse of 2x, right? So that gets cancelled, and 2x plus x, tan inverse of 3x, gets cancelled with tan inverse of 3x with a negative sign. So similarly all these terms would get cancelled, right? So you are left with this term and you're left with this term. To rewrite it, I would now have Sn, that's sum to infinity, being equal to tan inverse of n times x positive x and followed by tan inverse of x. So these are the two terms that are remaining. Now if I were to take x out, I would get tan inverse of n positive 1 times x negative tan inverse of x. So this is actually what is required, and hence proved, right? This is the right hand side and this is proved. Now there is one particular note I wish to give you. Now this is sum to infinity, or I should say sum of n terms, tan inverse of n positive 1 times x negative tan inverse of x, right? Now if they ask you to find the sum to infinity, S infinity, then this is going to be tan inverse of infinity added with 1 times x negative tan inverse of x, which is equal to tan inverse of infinity negative tan inverse of x. Tan inverse of infinity is pi over 2 negative tan inverse of x, which is nothing but cot inverse of x. So this is a very important result which can be asked, right? So that is the end of this particular problem, students. We'll move on to the next one. Students, we have this nice question. This question was asked in JEE Mains 2021, and the question is as follows. We are expected to find limit n tending to infinity of tan of sigma r is equal to 1 to n tan inverse of 1 over 1 positive r squared. Now this is equal to what? That's the question, right? Now clearly you can see that the general term is actually given here, so we don't have to extract the general term. So second step is we will have to somehow convert this to tan inverse of x negative y divided by 1 positive x times y, which is equal to tan inverse of x negative tan inverse of y. We have to ensure that this is converted to represent this so that we can apply this formula. So what I wish to do is I would start off with the quantity sigma tan inverse of 1 over 1 positive r squared. Let me take r out, so this is going to be written as r of r positive 1. That's fine. And r is moving from 1 to n, right? Now what I wish to do is I would like to take this as my x and this as my y and represent the numerator. So this is equal to sigma r is equal to 1 to n tan inverse of r positive 1 negative r. Clearly positive r negative r gets cancelled, giving me the term 1. So this is going to be 1 positive r of r positive 1, right? So this is my x, this is my y, and now I can make use of this formula. So this is equal to sigma r is equal to 1 to n tan inverse of r positive 1 negative tan inverse of r, right? So now actually r is moving from 1 to n, so I will have to make that substitution. So this is equal to first term r is equal to 1, so tan inverse of 1 positive 1 negative tan inverse of 1 plus n is r is equal to 2, so tan inverse of 2 positive 1 negative tan inverse of 2 plus r is equal to 3 tan inverse of 3 positive 1 negative tan inverse of 3, r is equal to 4, so tan inverse of 4 positive 1 negative tan inverse of 4, and plus etc up onto the nth term tan inverse of n positive 1 negative tan inverse of n. So clearly what you can see here is you can cancel the first term. Tan inverse of 1 positive 1 is 2, can be cancelled with negative tan inverse of 2, so this term gets cancelled. Tan inverse of 2 positive 1 is 3, this can be cancelled with negative tan inverse of 3. So likewise I can cancel all of these terms up unto this term. So the only term remaining are this and this. So if I were to rewrite this, this is equal to tan inverse of n positive 1 negative tan inverse of 1. But I've got tan already here. So let me place that. So this is equal to limit n tends to infinity of tan of, in place of this quantity, right? In place of this has already been simplified to represent this, which in turn is simplified to represent this. So I will substitute this. So this is equal to tan inverse of n positive 1 negative tan inverse of 1. So this is what we have got. Now n is tending to infinity. Since n is tending to infinity, we would have tan inverse of n positive 1. This is going to be limit n tending to infinity of tan of, this is going to be tan inverse of infinity negative tan inverse of 1. Now tan inverse of infinity is equal to pi over 2. Tan inverse of infinity is this, we know that. Tan inverse of 1 is going to be pi over 4. Now pi over 2 negative pi over 4, what is this? This is equal to limit. In fact, I have already applied the limit. I don't have to specify the limit, right? Applying a limit. So let me state that word. Applying limits, we get, right? Because of application of limits only we are getting this. So we don't have to state the limit again. So what have we got? We've got tan of, if I were to take the LCM as 4, this would be 2 pi negative pi. Hence we would now have tan of pi over 4. But what is tan of pi over 4? That's tan 45, which is equal to 1. And that is the solution for this question, students. So this is a beautiful question, and we will move on to the next one. Welcome, students. This question was asked in JEE Mains 2021. We got a beautiful question. The question is as follows. Cot inverse of alpha is given to be equal to cot inverse of 2, positive cot inverse of 8, positive cot inverse of 32 up until 100 terms, and we expected to find the value of alpha. Now alpha has to be one of these 4 choices. So we got 1.01, 1, 1.02 and 1.03. So there is one more term here. So that term is going to be cot inverse of 18. So I have written the terms 2, 8, 18, 32 and so on. Now what I wish to do is I would like to extract the difference between 2 and 8, that's 6. And then 8 and 18, that's going to be 10. And between 18 and 32, that's going to be 14, right? Now obtain the difference between 6 and 10, that's going to be 4. Obtain the difference between 10 and 14, that's going to be 4. Now obtain the difference between 4 and 4, that's going to be 0. Now what we are going to do is we are going to utilize this section of terms, right? So what is that? That's going to be 2, 6, 4 and 0. So we will have to extract the general term using these terms. So when we're writing the general term, this is going to be represented as t sub xn is equal to 2 positive 6 times of n negative 1 divided by 1 factorial positive 4 times of n negative 1 times n negative 2 divided by 2 factorial. Now 0 has got no meaning, right? So we are going to be dropping it, so we don't need that. So this is further rewritten as 2 positive 6 and negative 6. Now 2 factorial is 2, so that divides 4 twice, so this is going to be 2 times of n negative 1 times n negative 2. So let me distribute that. That's going to be n squared negative 2 times n and followed by negative n and positive 2. So this is equal to 2 negative 6, that's one term, positive 6n. Now let me just distribute 2. So this is going to be 2 times n squared negative, this is 2n negative n, that's going to be negative 3n multiplied with 2 is going to be negative 6n, positive 2 times 2 is 4. Now I got a 2 negative 6, that's negative 4, positive 4 gets cancelled, positive 6 and negative 6n gets cancelled, giving me positive 2n squared. So this is going to be my general term. So what I'm going to do is I am going to represent this given system, okay, as Therefore, cot inverse of alpha is equal to sigma. I'm going to write this as cot inverse of, in place of all these terms, I'm going to have 2n squared, but I'm not going to use n, I'm going to use 2r squared, where r is equal to 1 to 100, because it says that the terms are stretching up onto 100 terms. Now I can rewrite this cot inverse of 2r squared as sigma r is equal to 1 to 100 tan inverse of 1 over r squared, right? So let me write that down. Now the objective is to get the representation as tan inverse of x negative y divided by 1 positive xy. So this is our objective. Now with this quantity 1 over 2r squared, it is impossible to achieve this objective. So what I wish to do is, I would like to rewrite this sigma tan inverse of 1 over 2r squared by multiplying the numerator by 2 and the denominator by 2. So I get 2 over 4r squared. That's fine. Now as I mentioned to you, I would want a quantity in this fashion, x negative y divided by 1 positive xy. So in the denominator I have to have 1 positive. So how do I get that? So this is equal to sigma tan inverse of 2 over, as I mentioned to you, I need to have a 1 there. So I place a 1, 4 times r squared. Now since I placed a 1, I need to get rid of that 1. So this is what that is occurring, right? If I place 1 here, I need to get rid of it. So there is a negative 1 there. Now I can further rewrite this as tan inverse of 2 over, now 4r squared negative 1, I can club it as one quantity. So this is going to be 4r squared negative 1. Right? Now this is of the form a squared negative b squared, which is a negative b times a positive b. So using that form, this is equal to sigma tan inverse of 2 over 1 positive 2r negative 1 times 2r positive 1, right? Now I need to get x negative y, and I've got just 2 there in the numerator. So I would like to write this as 2r positive 1 negative 2r negative 1. Now you might be wondering, why did I choose 2r positive 1? Why not I choose 2r negative 1? The reason being, if I were to place a negative sign, 2r with a negative sign and 2r with a positive sign will get cancelled, giving me negative of negative 1, that's going to be positive 1, which can be added with this one, giving me 2. That is the reason. So my quantity is now going to be 1 positive 2r positive 1 times 2r negative 1. So this is going to be my x negative y. So this can be further rewritten as, now what is this? This is nothing but tan inverse of x negative tan inverse of y, right? So this is equal to, this is going to be my tan inverse of x negative tan inverse of y, right? But apparently we have to use, in place of x, I need to use, this is for your understanding, you don't have to specify it. So this you know, you can just box it off. So in place of x, I'm going to have tan inverse of 2r positive 1 negative tan inverse of 2r negative 1, and the values of r is stretching from 1 to 100, right? So that is what we have got. Now if we were to write the terms out for r is equal to 1, I would get tan inverse of 2 positive 1, right? R is equal to 1, so this is going to be 3 negative 2 times 1 negative 1, that's going to be tan inverse of 1 positive, when r is equal to 2, 4 positive 1, that's going to be 5 negative 4 negative 1, that's going to be negative negative tan inverse of 3. Now positive r is equal to 1 is done, 2 is done, 3. Now when I say 3, I would get 3 2s are 6, 7, negative tan inverse of 3 2s are 6, negative 1, tan inverse of 5 with the negative side. So on and so forth it goes. All the way we have to take the value when r is equal to 100. So this is going to be plus tan inverse of 100 when I substitute would give me 200 positive ones. So that's going to be 201. Negative 100 when I substitute is going to be 200 negative 1. That's going to be 199, right? 200 you take away from 200 you take away 1. You're going to get 199, right? Now if you were to start the cancelling spree, now clearly you can see tan inverse of 3 and tan inverse of 3 can be cancelled, tan inverse of 5 and tan inverse of 5 can be cancelled, and so on and so forth. Finally we would be just left with this term and this term. So let me write that down. So this is equal to tan inverse of 201 negative tan inverse of 1. We know the value for this, right? This can be easily obtained, but the question is how are we going to simplify this? Now this can be further simplified using the formula. So we clearly know that tan inverse of x negative tan inverse of y is equal to tan inverse of x negative y divided by 1 positive xy. We know this. So if I were to use that formula, this is going to be tan inverse of x negative y divided by 1 positive x times y. So this is going to be tan inverse of 201 minus 1 would give me tan inverse of 200 over 1 added with 201 times 1, that's going to be 202, right? So this is what we've got. Now if I were to divide this or reduce this by 2, this is going to be 100 divided by 101. Now I can rewrite tan inverse with cot inverse. So if I were to do that, this will get flipped, 101 divided by 100, right? But on the left hand side we got cot inverse of alpha, right? And we are expected to find the value of alpha. So cot inverse of alpha is equal to cot inverse of 101 divided by 100. So clearly cot inverse on either side gets dropped, giving me alpha is equal to 101 divided by 100, which means 1.01. So this is the value of alpha, hence the correct choice is choice A. So that is the solution for this question. Students, we'll move on to the next one. Students, this question was asked in JEE Main 2021. This is a lovely question, students, and we are expected to find the value of tan P given that sigma r is equal to 1 to 50, tan inverse of 1 over 2 r squared is equal to P. So the general term is actually given here. So what I wish to do is I would like to consider this quantity, sigma r is equal to 1 to 50, tan inverse of 1 over 2 r squared. Then I would rewrite this as sigma r is equal to 1 to 50. Now tan inverse of 1 over 2 r squared, I'm going to multiply the numerator by 2 and the denominator by 2. So this is going to be giving me sigma r is equal to 1 to 50 tan inverse of 2 over 4 r squared. Now my expectation is to have a representation of this form, tan inverse of x negative y divided by 1 positive xy. So I am working towards this. So this is going to be equal to sigma r is equal to 1 to 50. Now 4r squared, I need to have a 1 here, right? So the denominator can be rewritten as 1 positive 4r squared negative 1 with 2 being in the numerator, and this is nothing but tan inverse. Now I can club these two together and rewrite this as sigma r is equal to 1 to 50 tan inverse of 2 over 1 positive 4r squared negative 1. Now this is of the form a squared negative b squared, which can be split as a negative b, a positive b. So this is equal to sigma r is equal to 1 to 50 tan inverse of 2 over 1 positive 2r negative 1 times 2r positive 1. Now I need to get composition of two terms, x negative y. So the only way possible is to write 2 as 2r positive 1 negative of 2r negative 1 divided by 1 positive 2r positive 1 times 2r negative 1. Now you might be asking me, why did I take x to be as 2r positive 1? If I would not have taken, I would not be able to get this 2 here. Clearly you can see 2r positive 1 negative 2r positive 1. Negative 2r positive 2r gets cancelled, leaving me with 2. So that is the reason. So now this is nothing but sigma r is equal to 1 to 50 tan inverse of 2r positive 1 negative tan inverse of 2r negative 1. So this is what I've got. Now let me just take the subsequent terms from r is equal to 1 to 50. So if I were to do that, now r is actually ranging from 1 to 50. So this is going to be equal to, now let me just substitute r is equal to 1. So if I were to do that, I would get tan inverse of 1, that's going to be 2 positive 1, that's tan inverse of 3 negative tan inverse of 1 added with r is equal to 2, 4 minus 1, that's going to be this is going to be 5. It's not minus 1, it's plus 1. So this is 5 negative 4 minus 1, so it's going to be tan inverse of 3. Now next, this is 1 2 3 6 and 7, so I would get 7 here, and I would get tan inverse of 5 here, then I would get tan inverse of 9 here, I would get tan inverse of 7 here, and so on and so forth. It goes up unto r is equal to 50. When r is equal to 50, I get 101 tan inverse of 101 negative 50, that's going to be 100 minus 1, that's going to be tan inverse of 99, right? Now clearly you can see that this term and this term can be cancelled, this term and this term can be cancelled, this and this can be cancelled, this and this can be cancelled, subsequently this and this can be cancelled, giving me this is equal to tan inverse of 101 negative tan inverse of 1. Now this is tan inverse of x negative tan inverse of y. So again we can apply the required formula. So this is going to be tan inverse of x negative y divided by 1 positive x times y. So this is equal to tan inverse of 101 negative 1 is 100, 1 positive 101 times 1, that's going to give me 102. Now if I were to divide this by 2, I would get tan inverse of 50 divided by 51. Now on the left hand side we started with p, the question wants us to get tan p. So if I were to push this to the left side, this would mean I have tan p is equal to 50 over 51. This is what I've got. Now if you were to go and check the choices, we are given a set of choices. Apparently I need to mention those choices. A is 101 divided by 102, B is 50 divided by 51, C is 100, and finally D is 51 divided by 50. Now clearly we have got 50 divided by 51, right? So B is the right choice. So having obtained the solution for this question, we'll move on to the next question, students. We got a beautiful question, students. The question reads as follows. We are expected to find the value of tan inverse of 4 over 7 positive tan inverse of 4 over 19 positive tan inverse of 4 over 39 positive tan inverse of 4 over 67. This goes all the way to infinity, and we are expected to find the value. What is it equal to? Now foremost, what we have to do is we will have to obtain the general term. So for that, let me take down, in the numerator it's 4 4 4 4, so there isn't much to be done in the case of obtaining the general term for the numerator, because it's clearly going to be 4, right? But for the denominator, we got 7, 19, 39, 67, so on and so forth. So like I mentioned to you in the earlier problem, we will have to find the difference between 7 and 19. That is going to give me 12, and the difference between 19 and 39, that's going to be giving me 20. And the difference between 67 and 39, so we got 67 here, and we will take away 39, that's going to give me 8, and 5 and 28. So place the value 28 over here. Now find the difference again between 12 and 20, that's going to be 8. Find the difference between 28 and 20, that's going to be 8. Find the difference between 8 and 8, that's going to be 0. Now this is your benchmark, so we are going to use this to obtain the nth term. So we got 7, and we got 12, and we got 8. So we don't have to do anything with this, but in case of 12, we need to multiply it by n negative 1 and divide by 1 factorial, place a positive sign, and this is nothing but n negative 1 times n negative 2 divided by 2 factorial. Now rewriting, this is going to be 7 positive 12 times n negative 12 positive 2 divides 8, 2 factorial is 2, right? 2 divides 8 4 times, so this is 4 of n into n square, n into negative 2, negative 2n, negative n, positive 2. This can be rewritten as 7 positive 12 times n, negative 12, positive, I distribute the quantity, 4n squared, this is 3n with a negative sign, that's going to be negative 12n, positive 8. So positive 12n, negative 12n gets cancelled, and I can add 7 with 8, that's going to be 15. So 15 negative 12 positive 4n squared will give me 4n squared positive 3. So this is what I've got. So this is going to be my nth term. So when I'm writing the series, I'm going to write it in this fashion, right? Sigma terms are to infinity, right? So let me take it as r is equal to 1 to infinity. R is equal to 1 to infinity of 4n squared positive 3. Now this can be, anyway I will take it as n because that's better. So in the numerator it's going to be 4, in the denominator I got 4n squared positive 3. Now what I wish to do is I would like to take 4 out, and this would give me n squared positive 3 over 4. Now as I mentioned to you, our benchmark is actually to represent this as tan inverse of x negative y divided by 1 positive x into y. So this is our requirement. So we are trying to achieve this, okay, over here. So this is going to be 4 can be cancelled. So I got sigma n is equal to 1 to infinity 1 over. Now I need to have a positive one, so I'm going to write it as 1 positive n squared. Now this is 3 over 4. So can I actually write it as negative 1 over 4? If I were to place negative 1 over 4, 4 times 1 is 4, negative 1 gives me 3 over 4. So that's perfectly fine. So I would like to club these two together. So this is going to be sigma 1 to infinity and 1 over 1 positive n negative 1 over 2 times n positive 1 over 2. So this is what we have got. I need to have a quantity x negative y in the numerator. So this is equal to sigma 1 to infinity. I'm going to write this as n positive 1 over 2 negative of n negative 1 over 2 divided by 1 positive n positive 1 over 2 times n negative 1 over 2. Now clearly if you were to remove the parenthesis, negative n positive n gets cancelled. 1 negative of negative 1 over 2 will give you 1. So that's fair enough. Now this can be further rewritten as sigma, right? This is two terms together. So 1 to infinity tan inverse of my, in fact I need to have a n here, right, because this is n that we are using. So n positive 1 over 2. So n and negative n will get cancelled. So if we don't place that n, we will end up with the issues. So this is going to be tan inverse of x negative tan inverse of y, right? So n positive 1 over 2 negative tan inverse of n negative 1 over 2. So this is what we've got. Now this is actually stretching from 1 to infinity, right? Now we don't have to take 1 to infinity. We can take actually finite number of terms, right? And then we can study the series, and then from there onwards we can extend to infinity. We can extend the series to infinity. So that would be a very good idea. That's exactly what we're going to do now. So we will be taking finite number of terms. Now n is equal to 1. This is going to give me 1 positive 1 over 2. That's going to be tan inverse of 3 over 2 negative 1. That's going to be tan inverse of 1 over 2. And n is equal to 2. That's going to be tan inverse of 5 over 2. This is going to be tan inverse of 3 over 2. And this is going to be tan inverse of 7 over 2. This is going to be tan inverse of 5 over 2. So moving on like this up until n terms. So this is actually, I'm taking sum to n terms I'm taking. So when we have the nth term would be in this fashion: tan inverse of n positive 1 over 2 negative tan inverse of n negative 1 over 2, right? Now clearly if you were to cancel it, this term will get cancelled with this term will get cancelled with this, and this term will subsequently get cancelled with this, and so on and so forth, finally leaving us with this term also will get cancelled, this term and this term. So this is going to be tan inverse of n positive 1 over 2 negative tan inverse of 1 over 2. This is what we got. Now this is Tn, n terms, right? But n is tending to infinity, sum to infinity. So as n tends to infinity, this is going to be tan inverse of infinity. Now what is tan inverse of infinity? Tan inverse of infinity is going to be pi over 2 followed by negative tan inverse of 1 over 2. So this is going to be the solution for this question. Thank you students. We will see you all in the next class.